Then free from any dust or. Hi friends, welcome to my technical series of coating. In today's session I'll be explaining about the phosphating, the different types of phosphating, and I'll be explaining in detail about each type of phosphating. Now let me go into this lecture directly. Phosphating, see, is a kind of a metal pretreatment given on any metal components so that we can have a very good film built of paint, as well as it improves the adhesion of the paint so that the overall paint performance will be better, especially the corrosion resistance, water resistance, etc. And this kind of metal pretreatment is interpreted in terms of phosphate coating. After all, that is, we are giving a layer, we are cleaning first with some suitable solvent or alkaline degreaser, and make sure that it should be totally free from any dust, oil, grease, etc. So that it should be like a virgin metal. It should be very, very raw. It means what? That is totally free from, the metal surface should be totally free from rust, dust in any form. Okay, so make the surface perfect. I'll be talking about the cleaning of various metals in the subsequent videos. But before that, I just wanted to tell that that is a good metal treatment can be achieved only by better metal cleaning. That is very important. Now let us go for this phosphate layer or phosphate coating. See, this phosphate coating, phosphate, let me explain about this phosphate first of all. That is PO4 3 minus. This is called phosphate anion. Phosphate anion. PO4 3 minus. Phosphate anion. It is the trivalent anion, and we have got various types of phosphate like calcium phosphate, that is very popular. Then sodium phosphate, potassium phosphate, zinc phosphate, iron phosphate, etc. Okay, but we are very focusing on the three types of phosphate, that is iron phosphating, zinc phosphating, then manganese phosphating, and in fact in those days they had lead phosphating, but because of environmental problem issues we have totally banned this. So there is no scope for lead phosphate. So let us forget about it. Let us focus on iron phosphating, zinc phosphating, manganese phosphating. Okay, right. In iron phosphating, for instance, the tentative coating weight will be almost 30 to 100 gram, 30 to 100 milligram per square feet. Okay, 30 to 100. Even it may vary, that is 300 to 1000 also. It depends on the type of coating. Then zinc. Zinc has light weight, medium weight, and heavy coating weight formulations. So there are three types of zinc phosphate coating. And manganese phosphate coating, here it is a heavy one, heavy coating. It is exclusively meant for, that is, oiling and greasing. So it is not entitled for any painting. Okay, so for it acts as a very good lubricant, and that is why it forms a very rough surface, porous surface of manganese phosphate. So manganese, that is 1000 to 3000 milligram per square feet. Zinc phosphating, so it has got light, medium, and heavy types. Light has 100 to 400 milligram per square foot. Light has 100 to milligram per square foot. That means that is for 1 square foot it can deposit 100 to 400 milligram. Okay, and similarly medium is 450 milligram to 1000 milligram per square foot. It means that is we can coat that is a zinc phosphate of coating weight. Actually it is interpreted in terms of weight only. So 450 to 1000 milligram per square feet. Next, heavy. So heavy is intended generally for even greasing and that is a waxing. So here or tubing also. So heavy 1000 to 3000 milligram per square foot. So with the increase of coating weight, actually it's the roughness, coating roughness will be more, and there will be a lot of porosity also. So if there is more porosity, that is not good for corrosion resistance. So, but at the same time, it can absorb the oil and waxes, and for that purpose, that is a heavy coating is recommended. And for corrosion resistance, by painting, either by liquid paint or powder painting, you can go for that is light to medium. Okay, right. And now let us focus on iron phosphating. Iron phosphating actually is very thin coating. Okay, so it is amorphous. Amorphous means that is non-crystalline. It is not crystalline, right? And it is almost virtually it is invisible. You cannot find so clearly the coating formation, even though the color may be uniform iridescent blue, we used to say, or bluish gray. And then the coating weight ranges from 30 to 100 milligram per square foot. So normally in terms of gram means 0.3 to 1 gram per square meter. Okay. Then paint adhesion is improved with the help of this iron phosphate coating. So what you do is, if you have got any component, and let me consider this component. So we have got the component here. Okay. So first you have to clean it properly, and after ensuring oil free, dust free, rust free surface. Okay. Then you can give a coating of iron phosphating. So if it is mildly coated, then you can give in fact, that is furniture enamels, furniture paints are given on that is a lightweight iron phosphate coatings. Okay, so that is recommended. But if you insist for salt spray with the better salt spray resistance, that is corrosion resistance with better salt spray resistance, usually salt spray is the testing parameter that is useful for measuring the extent of corrosion resistance. Okay, so we used to give in terms of salt spray hours, salt spray resistant hours, according to ASTM B117. So here that is normally that is for certain components, probably that is they may insist for 100 or 200 hours, and in some cases 400 hours, in some cases 600 to 800 hours. In cases of tractors and other heavy weight equipments and machineries and automobiles, they may even go for 1000 hours of salt spray. Okay, so based on the type and nature of coating, that is the corrosion resistance can be enhanced. Okay, right. Now the paint adhesion can be improved with the help of this iron phosphate undercoat. Then you can when I say paint adhesion, adhesion of liquid paint as well as powder coating. Okay. Then as I already mentioned, corrosion resistance. So it should be rust proof. That is, the rust should not be developed after painting. You know, that is sometimes after all, that is a painting is done for maintenance purposes and the decorative purpose. Aesthetic value is there. At the same time, it should have some decorative purpose as well as the protective purpose. Okay, right. Then the substrate generally for iron phosphating can be mild steel. Okay. Then uniform blue to bluish gray color is obtained by this kind of iron phosphating. Okay, right. Then where you have to that is treat these components, you can have stainless steel bath where you can dip, as spray phosphating formulations are also available. In case of immersion, that is you have to you should have some good stainless steel bath. And then spray or dip, as I already told you, the method of applications can be spray or dip. Okay. Hi friends, welcome to my technical session. In this session, I'll be explaining about manganese phosphating. So in the previous lectures, I've been already talking about iron phosphating, zinc phosphating, and the introduction about the phosphating. So please go through previous videos, and in continuation of those videos, I am proceeding with this lecture on manganese phosphating. Manganese phosphating. So actually that is the manganese is represented by Mn, and it's a phosphate, that is a PO4 3 minus, and it's in fact the specialty of manganese is its variable valency from manganese +2 to +7. For example, in the case of potassium permanganate KMnO4, its valency is +7. Okay, and here there is a manganese sulfate, that is Mn2SO4, Mn, this is thrice. Okay, so Mn3SO4 twice, but you cannot expect such straight formula for manganese phosphate coating. It would be a combination of that is a hydrophosphate, hypophosphate, phosphate, manganese phosphate, iron phosphate. So it is a complex type of crystals. Okay, you cannot directly expect the pure manganese phosphate. Okay, right. But the major content is manganese, and it's a heavy phosphate. And in fact, its coating weight is 1,000 milligram to 3,000 milligram per square feet. Suppose if you consider a component of 1 square foot surface, and it will form, that is a porous surface. Okay, and it will be coarser also. The crystal structures will be coarser. So likewise, the weight will be, that is 1,000 milligram to 3,000 milligram per square foot, and they are larger crystals. Okay, and as I already suggested, that is they form very thick coating. So this is not suitable for painting, so you must understand that one. But probably that is, it may be useful for greasing, oiling, and it will be useful mainly applied on vehicles like aircraft, helicopter components, heavy automatic gears, steering parts, etc. Okay, then suppose if you want to reduce the particle size, what you can do is you can introduce that is surface conditioner prior to phosphate bath. Okay, and then you have got that is, it will withstand very good temperature, high temperatures also. Then the color will be dark gray or black. It is sometimes semi-decorative only, but you cannot leave it. You can leave this as such by oiling. Okay, and then as I already suggested, no coating is recommended, but oiling can be done, oiling, greasing, etc. Then immersion type, this is of immersion type. Okay, and as I already suggested, this is of heavy duty nature. Okay, so it's a heavy coating type. Hi friends, how are you? In today's session, I'll be explaining about zinc phosphating. This is one of the most frequently used metal pretreatment by many metal finishing industries. Zinc phosphating. You know the formula of zinc, Zn, and the phosphate PO4 3 minus. So you can combine this, and this is zinc 2 plus. But as you expected, it will not contain only zinc phosphate. Along with that, you will be having iron phosphate also. But this iron phosphate, when it becomes a ferric phosphate, that is thrown out as the sludge. So it is a combination of phosphates, and major you have got the zinc ion and phosphate ion. Okay, and here we have 3 types of zinc phosphate. One is lightweight zinc phosphate. It is fine and crystalline. In fact, in spray type, we have got 2 types of application, dip type and spray type. In spray type, you will be able to get lightweight, fine, crystalline phosphates, phosphate crystals. And this can also be used for dipping. Whereas, based on the coating weight, they are classified into lightweight, medium weight, heavy weight. Lightweight means the coating weight per square feet is 100 milligram to 450 milligram. Whereas it can be interpreted in terms of gram per square meter also. What you have to do is just divide by 10, so that 1 gram to 4.5 gram per square meter. And then medium weight 450 milligram to 1000 milligram per square feet. So here somewhat heavier than the lightweight. Of course, it is a medium. So 450 milligram to 1000 milligram per square feet. And in terms of gram, 4.5 gram to 10 gram per square meter. When you take 1 square meter component, it will coat 4.5 gram to 10 gram. Okay, so this is known as medium weight, and these two are applicable for coating industries, where after treatment of phosphating, they will give the top coat, the finish coat, with liquid paint or powder coat. And the third variety is heavy weight. So here 1000 milligram to 3000 milligram per square feet, that is 10 gram to 30 gram per square meter. Okay, so here it will be slightly porous, and it may not have aesthetic appearance, and it will have a matte finish also. So if you want to have a super glossy finish with a single coat of finish or double coat of finish, then I would suggest you go for lightweight, where you cannot get the highest corrosion resistance. There will be moderate corrosion resistance in terms of salt spray hours, resistance hours. But when you go for medium weight, this is always ideal for any automotive industries. And this is somewhat a super weight nature. Okay, so with the increase of coating weight, you can have better corrosion resistance, but it will sometimes complicate also. So heavier the coating, it will have the hygroscopic tendency, so that the water test may be a failure. Okay, so take care. I would always suggest to go for the medium weight. Now, apart from that, we can have a single pack phosphating system or dual pack with the accelerator. Okay, so in my opinion, always go for dual pack with the accelerator. Okay, of course, heat energy is required around 50 to 55 to 70 degrees centigrade, but that is the ideal phosphating. But as far as the cold process is concerned, it will take a longer duration. Okay, and not only that, it is not so efficient as that of dual pack also. And the better crystal lattice pattern can be achieved only by 55 to 70 degrees centigrade by using appropriate accelerators. Accelerators are nothing but oxidizing agents like nitrate, nitrite, chlorate, nitroguanidine, etc. Okay, so in single pack, it can be done at room temperature itself, but in a dual pack, you have to maintain the temperature. And I'll be talking about the heating element and what are the expected problems while processing the phosphate, so that it should be useful in the shopping floor level. Then I need to talk about the calcium modified zinc phosphate also. So here it will incorporate the formulator will incorporate some calcium salts, so that it will be finer. The coating will be finer, very smooth, and it has less sludge also. So the major problem with phosphating is the sludge. So nowadays, that is nano coating has been developed based on zirconic acids. So I will talk about that zirconia coatings also. So this is the latest nano coating technology, so that it will be eco-friendly and economical also. And not only that, the maintenance of bath will be very easier, and you won't get any sludge. And not only that, it will have the finest coating. Okay, and it will be ideal for liquid painting as well as powder coating. Okay, and there are a lot of inquiries for nano coating also. So if you are interested, you can send your inquiries. Okay, right. So in the next session, I'll be explaining about how to maintain a bath. Okay, so this is very, very important, and how to construct a bath. and if there is any problem in the process, what are all the important parameters you have to look into that, okay, and what are the parameters to be maintained, all these details will be given in my next video, okay. So thank you for watching this video. Zinc phosphating அப்படிங்கிறது ரொம்ப முக்கியமான ஒரு மெட்டல் ப்ரீட்ரீட்மெண்ட். இந்த வகையான மெட்டல் ப்ரீட்ரீட்மெண்ட்டில் நாம் ரெண்டு விதமாக பண்ணுவோம். ஒன்று வந்து கோல்டு பாஸ்பேட்டிங் சொல்லுவாங்க, இன்னொன்று இம்மர்ஷன், ஹாட் இம்மர்ஷன் பாஸ்பேட்டிங் அப்படின்னு பேர். ஸோ எல்லாத்துலேயுமே பார்த்தீங்கன்னாக்கா டென்டேட்டிவாக அந்த 7 ஸ்டேஜஸ் அப்படிங்கிறது ரொம்ப முக்கியம். எந்த ஒரு பாஸ்பேட்டிங் எடுத்தாலும் உங்களுடைய மெட்டல் வந்து பக்காவாக க்ளீனாக இருக்கணும். நான் அடிக்கடி சொல்கிற மாதிரி, சரியா? இந்த மெட்டல் க்ளீனிங் வந்து அதை ஆயில் இருந்ததுனாக்கா, க்ரீஸ் இருந்ததுனாக்கா அதை சுத்தமாக க்ளீன் பண்ணி ஆகணும். ஸோ நாம் பர்ஃபெக்டான ஒரு டீக்ரீஸிங் ஏஜென்ட்டை யூஸ் பண்ணணும். ஸோ இந்த டீக்ரீஸ் பண்ணிவிட்டு நல்லா வாஷ் அப் பண்ணிவிட்டு அதுக்கப்புறம் ரஸ்ட்டும் இருக்கக்கூடாது, சரியா? ஏதாவது ஸ்பாட் ரஸ்ட் இருந்ததுனாக்கா ஸ்பாட்டில் க்ளீன் பண்ணிடணும். அதுக்காக ஃபுல்லாக ஆசிட் டிப்பு போட்டிங்கன்னா இருக்கிற மெட்டலும் அக்ரிவேட் ஆகிடும். இப்போ அசிடிக் ஜாஸ்தி ஆயிடுச்சுனாக்கா அந்த பாஸ்பேட் கோட்டிங் அக்ரெசிவாக ஃபார்ம் ஆகிடும். ஸோ கோர்ஸராக இருக்கும், அது ஃபைனராக இருக்காது. ஸோ அதனால் டீரஸ்டிங்கை நீங்கள் கூடுமான வரையில் அவாய்ட் பண்ணணும். அப்படின்னா என்ன அர்த்தம்? டோட்டலி யூ ஷுட் ப்ரொக்யூர் தி ரஸ்ட் ஃப்ரீ காம்பனன்ட்ஸ் ஒன்லி. ஆனால் வெளியிலேருந்து வர்றது நல்லா தான் இருக்கும், ஷீட் மெட்டல்லாம் வாங்குவீங்க. ஆனால் நீங்கள் அதை ஸ்டோர் பண்ணுற விதம் பார்த்தீங்கன்னா கேவலமாக வச்சுருப்போம் நம்ம. அதை வந்து அதாவது நாம் என்ன நினைக்கிறோம் அப்படின்னா, ப்ராடக்டாக ஃபார்ம் பண்ணதுக்கப்புறம் தான் அதை வந்து ஒரு பக்கா ஸ்டோர் ரூமில் வைக்கணும் அப்படின்னு நினைக்கிறது தப்பு. ஆரம்பத்துலேருந்து அந்த ஸ்டோரேஜ் வந்து பர்ஃபெக்டாக இருந்ததுனாக்கா உங்கள் ஷீட் மெட்டல் காம்பனண்ட்டு எந்த விதமான இதுவும் பிரச்சனையும் இல்லை. ஏன் அப்படின்னா அங்கே ஷீட் மெட்டல் காம்பனண்ட் உங்களுக்கே தெரியும், அந்த ரா மெட்டல்லாம் உள்ளே வரப்பையே பக்காவாக ஆயிலிங் பண்ணி தான் வருது, க்ரீஸிங் பண்ணி தான் வருது. அதில் ரஸ்ட்டு இருந்ததுன்னா, ஸ்பாட் ரஸ்ட் இருந்ததுனாக்கா அப்போயே க்ளீன் பண்ணிட்டு மறுபடியும் ஆயில் பண்ணி போட்டுருங்க. இல்லாட்டினாக்கா யூ டாக் டு யுவர் சப்ளையர். ட்ரை டு கெட் தி ஷீட் மெட்டல் டோட்டலி ஃப்ரீ ஃப்ரம் ரஸ்ட். ஆனால் உங்கள் எண்டில் வந்ததுக்கப்புறம் உங்கள் யார்டில் அதை கேவலமாக அப்படியே டைரக்ட் எக்ஸ்போஷர் டு சன்லைட்டு, வாட்டர் அப்படின்னு வச்சிங்கன்னா அது வந்து நீங்கள் உங்களுடைய பேஸ் மெட்டலே கெடுத்துடுறீங்கன்னு அர்த்தம், சரியா? அதுக்கப்புறம் நீங்கள் என்ன பண்ணுவீங்க, நல்லா ரஸ்ட்டாக விட்டுட்டு அதை டீரஸ்ட் பண்ணுறேன்னு சொல்லிட்டு ஆசிடில் டிப் பண்ணுவீங்க. கூடுமான வரையிலும் டீரஸ்டிங் கெமிக்கலே யூஸ் பண்ணக்கூடாது. நீங்கள் என்னுடைய சஜஷன் என்னன்னாக்கா, டீக்ரீஸ் பண்ணலாம், பக்காவாக ஃப்ரீ பண்ணிக்கோங்க. இந்த டீக்ரீஸ் அப்படிங்கிறது ஆல்கலைன் டீக்ரீசர் யூஸ் பண்ணலாம், இல்லாட்டினா வேப்பர் டீக்ரீசிங் மெத்தட் இருக்குது, இல்லாட்டினா சால்வெண்ட் டிப் மெத்தட் இருக்குது. ஸோ இது மாதிரி வெரைட்டி ஆஃப் மெத்தட்ஸில் நீங்கள் அக்ளைன் பண்ணிக்கலாம், சரியா? ஸோ நீங்கள் ஃபாஸ்பேட்டுக்கு முன்னாடி நீங்கள் பண்ண வேண்டிய மிகப்பெரிய முக்கியமான ஒரு விஷயம் என்ன அப்படின்னா, த சர்ஃபேஸ், மெட்டல் சர்ஃபேஸ் ஷுட் பி டோட்டலி ஃப்ரீ ஃப்ரம் ரஸ்ட், டஸ்ட் இன் எனி ஃபார்ம், ஆயில் ஆர் கிரீஸ். இது எல்லாம் க்ளீனாக இருக்கணும். அதுக்கப்புறம் தான் அது ஜிங்க் ஃபாஸ்பேட்டிங்க்கு ஃபிட்டஸ்டான ஒரு கேண்டிடேட் அப்படின்னு சொல்லலாம், சரியா? ரைட். இப்போ அந்த மாதிரியான ஒரு டீக்ரீஸ்லாம் முடிச்சுட்டு வாஷ் அப் பண்ணிட்டு ரெடி பண்ணி வச்சுருந்தீங்கன்னா தென் யூ கேன் புட் இட் இன் த பாத், ஜிங்க் ஃபாஸ்பேட்டிங் பாத் அதில் பண்ணலாம். நிறைய பேர் கேட்குறாங்க என்கிட்ட கோல்ட் ஃபாஸ்பேட்டுன்ட்டு. ஐ ஜென்ரலி டு நாட் ரெக்கமெண்ட் கோல்ட் ஃபாஸ்பேட். ஏன்னா அந்த அளவுக்கு அவ்வளோ அக்குரேட்டாகவும் அவ்வளோ ப்ரிசைஸாகவும் அதில் கிறிஸ்டல் ஃபார்மேஷன் கிடைக்கிறதில்ல. உங்களுக்கு ஐடியலானது ஹாட் இம்மர்ஷன் டைப் தான். எனிவே, ஸோ இது உங்களுடைய சொந்த விருப்பம். அதனால் நீங்கள் கோல்ட் ஃபாஸ்பேட் அப்படின்னா கோல்ட் ஃபாஸ்பேட் கிடைக்கும், ஹாட் ஃபாஸ்பேட்னாலும் ஹாட் ஃபாஸ்பேட் கிடைக்கும், ஸ்ப்ரே டைப்னாலும் ஸ்ப்ரே டைப்பில் கிடைக்கும், சரியா? ரைட். இப்போ ஆனால் ஒன்று நல்லா ஞாபகம் வச்சுக்கணும், ஸ்ப்ரே டைப் யூஸ் பண்ணுறப்போ கான்சன்ட்ரேஷன் லோயராக தான் இருக்கணும் ஸ்ப்ரே டைப்பில். வேறாஸ் டிப் டைப்பில் வந்து கிட்டத்தட்ட 3 to 4 or 4 to 5 or 5 to 6 டிபெண்டிங் ஆன் த கண்டிஷன் ஆஃப் த மெட்டல் சப்ஸ்ட்ரேட்டு உங்களுடைய பாத் கான்சன்ட்ரேஷன் மாறணும். அண்ட் நான் ஏற்கனவே சொன்ன மாதிரி இந்த டோட்டல் அசிடிட்டி, ஃப்ரீ அசிடிட்டி, அந்த ஆக்சலரேட்டர் கண்டென்ட்டு இதெல்லாம் வந்து நீங்கள் கரெக்டாக மானிட்டர் பண்ணிகிட்டே இருக்கணும், சரியா? ரைட். இப்போது நாம் சப்ஜெக்ட் வருவோம். இதில் ஜிங்க் ஃபாஸ்பேட்டிங் அப்படிங்கிறப்போ 3 டைப் இதில் பார்க்கலாம். லைட் வெயிட், மீடியம் வெயிட், ஹெவி வெயிட். லைட் வெயிட் எல்லாம் ஃபைன் கிறிஸ்டலைன் ஸ்ட்ரக்சர்ஸ் கொடுக்கும், 100 mg to 450 mg per square feet. அதே மாதிரி இதை எப்போது சில ஆர்கனைசேஷனில், சில கம்பெனிஸில் ஸ்கொயர் மீட்டரில் கேட்பாங்க. ஸோ அப்போ நீங்கள் என்ன பண்ணணுன்னா 100 mg to 450 mg per square feet அதை மீட்டர் ஸ்கொயராக மாற்றுறப்போ ஜஸ்ட்டு 10ஆல் டிவைட் பண்ணிவிடுங்க, 100ஆல் டிவைட் பண்ணிவிடுங்க. அப்போது யூ வில் கெட் 1 gram, இங்கே வந்து 4.5 gram. அப்போ 1 gram to 4.5 gram per square meter அப்படின்னு சொல்லலாம். அதே மாதிரி மீடியம் வெயிட் 450 milligram to 1000 milligram. அப்போ 4.5 gram to 10 gram per square meter அப்படின்னு வரும். அதுக்கப்புறம் ஹெவி வெயிட் பார்த்தீங்கன்னா 1000 milligram to 3000 milligram per square foot. 10 gram to 30 milligram 30 gram per square meter. அப்போது இந்த கோட்டிங் வெயிட் இன்க்ரீஸ் ஆக நீங்கள் 3 விதமான பாஸ்பேட் கோட்டிங் ஃபார்ம் ஆகுது. இதில் நீங்கள் முக்கியமாக தெரிஞ்சுக்க வேண்டியது என்ன அப்படின்னா, உங்களுடைய கிளையண்ட்டை நீங்கள் கேட்கணும் என்னென்னா உங்களுடைய சால்ஸ்பே அந்த ஏன்னா எக்யூப்மெண்ட்டு காம்பனண்ட்டுக்கு தகுந்த மாதிரி இந்த கோட்டிங்கை நீங்கள் டிசைட் பண்ணணும். ஸோ அவங்க எவ்வளோ சால்ஸ்ப்ரே ஹவர்ஸ் கேட்குறாங்க அதுக்கு தகுந்த மாதிரி தான் நீங்கள் கோட்டிங் மெத்தட்ஸ் போகணும் இல்லையா. ரொம்ப ஹெவியாக கேட்டாங்கனாக்கா ஹெவி, அதாவது எல்லாம் 700 hours 800 ஹவர்ஸ்னால் ஆக்சுவலாகவே மாடரேட்டே போதும். மீடியம் வெயிட் ஜிங்க் ஃபாஸ்பேட்டிங்கு தட் இஸ் மோர் தென் எனஃப். இன்னும் கொஞ்சம் அதிகமாக கேட்டாங்கன்னாக்கா சில இடத்துல ஆயிலிங்காக கேட்பாங்க பாஸ்பேட்டிங், அந்த மாதிரி இதெல்லாம் ஹெவியாக போகலாம். அதுக்கப்புறம் ஈவன் சில இடத்துல ஹெவி வெயிட் ஜிங்க் ஃபாஸ்பேட்டிங் யூஸ் பண்ணுறாங்க ஆயிலிங்க்கு, சில இடத்துல வந்து மேங்கனீஸ் ஃபாஸ்பேட்டிங் யூஸ் பண்ணுறாங்க. அதுக்கப்புறம் மீடியம் பெயிண்டிங்க்கு, அதாவது லிக்விட் பெயிண்ட் அண்ட் பவுடர் கோட்டிங் ரெண்டுத்துக்கும் என்ன சஜஸ்ட் பண்ணலான்னாக்கா இந்த லைட் வெயிட் அண்ட் மீடியம் வெயிட்டு ரொம்ப ஐடியலாக இருக்கும். இப்போ நம்ம இந்த சப்ஜெக்ட் வருவோம். சிங்கிள் பேக் அண்ட் டியூவல் பேக்னு சொல்லலாம். சிங்கிள் பேக்னாக்கா அது நிறைய காம்பனன்ட்ஸ் இருக்காது, ஒரே சிங்கிள் பேக்கு அதை போட்டு டிசால்வ் பண்ணி அப்படியே அடிக்க வேண்டியதான். எல்லாமே பில்டினாக இருக்கும். கோல்ட் ப்ராசஸ் நான் ஏற்கனவே சொன்ன மாதிரி இது அவ்வளோ எஃபிஷியன்ட் கிடையாது. ஆனால் கோல்ட் ப்ராசஸ்ன்னு சொல்லிவிட்டு நீங்கள் அதில் காம்பனண்ட்டை போட்டுட்டு அதுக்கப்புறம் பாஸ்பேட் ஆகிடுச்சா அப்படி எடுத்து வைக்க வேண்டியதான். அதில் டியூவல் பேக்கில் வந்து பார்த்தீங்கன்னாக்கா ஆக்சலரேட்டர் எஃபிஷியண்ட்டாக இருக்கும், ஹாட் இமர்ஷன் டைப்பில் இருக்கும், 55 to 70 டிகிரி வரையிலும் போகலாம். அதுக்கப்புறம் அதுலேயே ஆக்சலரேட்டர்ஸ் ஆக்சிடைசிங் ஏஜென்ட்டு என்னென்ன யூஸ் பண்ணுறாங்க அப்படின்னாக்கா, இது நான் ஏற்கனவே சொன்ன மாதிரி டியூவல் பேக் காம்பவுண்ட் 1 காம்பவுண்ட் 2 இல்லாட்டினா காம்பவுண்ட் ஏ காம்பவுண்ட் பி இல்லாட்டினா ஆல்ஃபா பீட்டா ஆளுக்கு பேர் வச்சுப்பாங்க இஷ்டத்துக்கு. ஸோ அந்த 2 பேக்கில் இருக்கும். அப்பார்ட் ஃப்ரம் தட் ஒரு ஆக்சலரேட்டர் பேக் இருக்கும். ஸோ அதை கரெக்டாக நீங்கள் யூஸ் பண்ணணும். இப்போ இந்த ஆக்சிடைசிங் ஏஜென்ட் தான் இந்த ஆக்சலரேட்டர், அதாவது இந்த கோட்டிங் ஃபார்மேஷனை இன்க்ரீஸ் பண்ணும், ஸ்பீடாக இருக்கும். நைட்ரைட்டு நைட்ரேட்டு குளோரேட்டு அப்புறம் நைட்ரோகுவானிடின் இந்த மாதிரியான ஆக்சிடைசிங் ஏஜென்ட் தான் இந்த இதில் இருக்கும். இதெல்லாம் ஆக்சிடைசிங் ஏஜென்ட்லாம் கொஞ்சம் ஸ்டோரேஜ் ரொம்ப கேர்ஃபுல்லாக இருக்கணும். அப்ரோப்ரியேட் லைசன்ஸ் நீங்கள் வாங்கிக்கணும் ஃப்ரம் த ஸ்டாச்சுட்டரி அத்தாரிட்டிஸ். நீங்கள் ஸ்டோரேஜ் பண்ணுறது ரொம்ப கேர்ஃபுல்லாக இருக்கணும். ஏன்னா இதெல்லாம் எக்ஸ்ப்ளோசிவில் யூஸ் ஆகுது. அண்ட் தே ஆர் ப்ரோன் டு தேர் ஹைலி இன்ஃப்ளேமபிள், வெடிக்கக்கூடியது. ஓகே, ஸோ அதனால் நீங்கள் கேர்ஃபுல்லாக தான் இருக்கணும். டைரக்ட் சன்லைட்லாம் அப்படிலாம் போடக்கூடாது, பக்கத்தில் ஸ்பார்க் இல்லாமல் பார்த்துக்கணும். அதுக்கப்புறம் கால்சியம் மாடிஃபைடு இந்த பாஸ்பேட் வந்து பார்த்திங்கன்னா ஃபைனராக இருக்கும். அதுக்கப்புறம் ஸ்லட்ஜ் கம்மியாக இருக்கும். ஸோ இந்த மாதிரி ஜிங்க் ஃபாஸ்பேட்டிங்கே வந்து இத்தனை விதமாக பண்ணலாம். நான் இதில் ஒரு முக்கியமான ஒரு விஷயம் சொல்கிறேன். அதாவது ஏற்கனவே ப்ரீவியஸ் லெக்சரில் நான் ஃபஸ்ட்டு இன்ட்ரடியூஸ் பண்ணியிருப்பேன். அதாவது பாஸ்பேட்டு என்னென்ன டைப்பு, அதில் அயன் ஃபாஸ்பேட், மேங்கனீஸ் ஃபாஸ்பேட், அதுக்கப்புறம் ஜிங்க் ஃபாஸ்பேட் அப்படின்னு கொண்டு வந்திருப்பேன். அதில் லெட் ஃபாஸ்பேட் கூட இருக்குது. இப்போ லெட்டு வந்து பேன் பண்ணிட்டாங்கன்றதுனால அதை பற்றி பேச வேண்டாம். இந்த 3 பாஸ்பேட்டில் அயன் ஃபாஸ்பேட்டுன்றது இந்த ஃபர்னிச்சர் இண்டஸ்ட்ரீஸுக்கெலாம் கரெக்டாக செட் ஆகிடும். அங்கே வந்து ஏன்னா எல்லாமே இன்டோர் எக்யூப்மெண்ட்ஸ் தான் இருக்கும், ஃபர்னிச்சர்லாம் உள்ளே தான் போட போகிறோம். அதனால் சாஸ்ப்ரே வந்து அந்த அளவுக்கு எல்லாம் கேட்க மாட்டாங்க, கரோஷன் ரெசிஸ்டன்ஸ் அவ்வளோ ஹையாலாம் கேட்க மாட்டாங்க. வேறஸ் இதில் நீங்கள் கொஞ்சம் ஆட்டோமோட்டிவ் இண்டஸ்ட்ரீஸ் வந்துட்டிங்கனாக்கா இந்த OEM பீப்புளெலாம் இன்சஸ்ட் பண்ணுவாங்க சால்ட் ஸ்ப்ரே ஹவர்ஸுக்கு தகுந்த மாதிரி ஃபாஸ்பேட் எடுக்கணும். ஸோ லோயர் லெவல் பார்த்தாக்கா நீங்கள் ஜிங்க் ஃபாஸ்பேட்டை மைல்டு லெவலில் போகலாம், இல்லை கொஞ்சம் ஹெவியாக வேணும்னாக்கா மீடியம் லெவலில் வேணும், இன்னும் கொஞ்சம் சூப்பர் ஹெவியாக போகணுன்னாக்கா ஹெவி கோட்டிங்க்கு தான் போகணும். ஸோ பேஸ்ட் ஆன் த ரெக்குவயர்மெண்ட்டு தான் நீங்கள் அந்த ஜிங்க் ஃபாஸ்பேட்லாம் கிளாஸிஃபை பண்ணுறீங்க. எங்களுக்கு வந்து இல்லை சார் டியூபிங்கு ஆயிலிங்கு க்ரீஸிங் அடிக்கணும் அந்த மாதிரியான பார்ட்ஸுக்கள்னால் மேங்கனீஸ் ஃபாஸ்பேட்டிங் தான் பெஸ்ட்டு இல்லையா. இதெல்லாம் தவிர உங்களுக்கு சார் இதெல்லாம் பாஸ்பேட்டிங்கில் நாங்கள் அக்கம் பக்கத்தில் வச்சு பார்த்துட்டோம், ரொம்ப பொல்யூஷன் ப்ராப்ளம் இருக்குது அப்படின்னு எங்களுக்கு ஏதாவது எக்கோ ஃப்ரெண்ட்லியாக சஜஸ்ட் பண்ண முடியுமான்னு கேட்டிங்கன்னா நான் உங்களுக்கு சஜஸ்ட் பண்ணுறது நானோ கோட்டிங், அதாவது ஜிர்கோனியா பேசிஸில் அது வரும், ஜிர்கோனியம் ஆக்சைடு பேசிஸில் வரும். அதுக்கான ஃபார்முலேஷன்ஸ் எங்கள்கிட்ட இருக்குது, நீங்கள் வந்து அதை எஃபெக்டிவாக யூஸ் பண்ணிக்கலாம் சரியா. ஸோ இதை நாங்கள் நானோ கோட்டிங் மெட்டல் ப்ரீ ட்ரீட்மெண்ட்னு சொல்லுவோம். ஆல்மோஸ்ட் ஆன் பார் வித் ஜிங்க் ஃபாஸ்பேட்டை பக்காவாக ஃபார்முலேஷன் டெவலப் பண்ணியிருக்கோம். ஸோ இதை நீங்கள் எஃபெக்டிவாக யூட்டிலைஸ் பண்ணிக்கலாம் சரிங்களா. ரைட். ஸோ ஜிங்க் ஃபாஸ்பேட்டிங் அதாவது பாஸ்பேட்டிங் மெட்டல் ட்ரீட்மெண்ட் சம்மந்தமாக ஏதாவது உங்களுக்கு டவுட் இருந்தால் நீங்கள் தாராளமாக கமெண்ட் செக்ஷனில் கேட்கலாம். தேங்க்யூ வெரி மச் ஃபார் வாட்சிங் திஸ் வீடியோ. இந்த லெக்சரில் நம்ம என்ன பார்க்க போகிறோம் அப்படின்னா மேங்கனீஸ் பாஸ்பேட்டிங் அப்படிங்கிறத பற்றி பார்க்குறோம். ஏற்கனவே நம்ம வந்து அயன் பாஸ்பேட்டிங், அப்புறம் டைப்ஸ் ஆஃப் பாஸ்பேட்டிங் அப்படியெல்லாம் பார்த்தோம், ஜின் பாஸ்பேட்டிங். இப்போ அந்த சீரீஸில் மேங்கனீஸ் பாஸ்பேட் அப்படிங்கிறதையும் பற்றி பார்க்குறோம். ஸோ என்னுடைய ப்ரீவியஸ் வீடியோஸில் நீங்கள் கவனிச்சு பார்த்தீங்கன்னா அதை பற்றிய மெட்டல் ப்ரீட்ரீட்மெண்ட் எப்படியெல்லாம் பண்ணலாம், எதெல்லாம் ஒரு சஜஸ்டிவ் மாடல் கொடுத்துருப்பேன். அது அந்த வீடியோ கவனிச்சிங்கன்னா உங்களுக்கு ரொம்ப யூஸ்ஃபுல்லாக இருக்கும். இப்போது நாம் இந்த மேங்கனீஸ் பாஸ்பேட் அப்படிங்கிறத பற்றி பார்ப்போம். மேங்கனீஸ் பாஸ்பேட் அப்படிங்கிறது, தட் இஸ் மேங்கனீஸோட வேலன்சி வந்து அது வந்து வேரியபிள் வேலன்சின்னு சொல்லுவாங்க. அதாவது மேங்கனீஸோட ஸ்பெஷாலிட்டி என்னென்னா +2 +5 +7 இதெல்லாம் இருக்கும். Mn ரெப்ரசன்ட் பண்ணலாம். Mn+2 ஆக்சிடேஷன் ஸ்டேட்டு. இது +7 வரையில் வேரியபிள் ஆக்சிடேஷன் ஸ்டேட் இருக்குது. ஃபார் எக்ஸாம்பிள் பொட்டாசியம் பெர்மாங்கனேட் எடுத்துக்கிட்டிங்கன்னாக்கா KMnO4 இதோட ஆக்சிடேஷன் ஸ்டேட் வந்து Mn+7. அதே இது MnSO4 அப்படின்னு வந்ததுன்னா SO4க்கு -2 வேலன்சி, இதுக்கு +2 வேலன்சி. அப்போ இந்த இடத்துல +2 அப்படின்னு இருக்கும். ஸோ இந்த கேஸில் இப்போ மேங்கனீஸ் பாஸ்பேட் அதோட கெமிக்கல் ஃபார்முலா என்ன சார்னா, நீங்கள் நினைக்கிற மாதிரி ஸ்ட்ரைட் ஃபார்வர்டாக அப்படியே வெறுமனே மேங்கனீஸ் பாஸ்பேட்டுன்னு இருக்காது, அதில் ஹைட்ரேட்டடாகவும் இருக்கும். இப்போது அயன் பாஸ்பேட்டும் கலந்துருக்கும் அதில். ஸோ மேங்கனீஸ் 2++ PO4 3-. பாஸ்பேட் வந்து ஒரு ட்ரைவேலண்ட் ஆனியம். அப்போ இந்த ரெண்டுத்தையும் கம்பைன் பண்ணுறப்போ தட் இஸ் we are able to get Mn3PO4 twice அப்படின்னு வரும். ஸோ இது 2 times, இது 3 times. ஸோ இந்த மாதிரி எப்போதுமே ஒரு ஃபார்முலேட்டர் என்ன பண்ணுவாங்கன்னா, பக்காவாக கெமிக்கலி பேலன்ஸ்டாக இருக்கா அதெல்லாம் பார்த்து தான் ஒரு நல்ல ஃபார்முலேட்டர் பண்ணுவாங்க. எங்கேயோ யாரோ கொடுத்தாங்க ஒரு ஃபார்முலாவை, இல்லாட்டினாக்கா இன்டர்நெட்டில் தேடிட்டு அங்கே கிடைக்கிற ஃபார்முலாவெல்லாம் கொடுக்குறதா இருந்தாக்கா அது யூஸ்லெஸ். அது வந்து பேலன்ஸ்டாக இருக்கா கெமிக்கலி, அது வந்து அதோடைய அதாவது ஜென்ரலாக அந்த மாஸ் ரிலேஷன்ஷிப்லாம் சொல்லுவாங்க, மாஸ் ரேஷியோலாம் கரெக்டாக இருக்கா, இதெல்லாம் பார்த்து தான் ஒரு ஃபார்முலாவை அரைவட் பண்ணணும். அண்ட் பை எக்ஸ்பீரியன்ஸ்லேயும் சில பேருக்கு வரும். சரியா? ரைட். உங்களுக்கு இன்ட்ரெஸ்ட் இருந்ததுனாக்கா நான் பிற்பாடு ஒரு ஃபார்முலேஷனை எப்படி பண்ணுறது அப்படிங்கிறத நான் கன்வீனியன்ட் டயத்தில் உங்களுக்கு சொல்லித்தரேன். ரைட். ஸோ இப்போது இதில் நான் ஏற்கனவே சொன்ன மாதிரி 1000 mg to 3000 mg/sq ft வரையிலும் வரும். இது வந்து லார்ஜ் கிறிஸ்டல் சைஸ் இருக்கும். இதில் ஜின் ஃபாஸ்பேட், அயன் ஃபாஸ்பேட்லாம் பார்த்தீங்கன்னா சின்னதாக இருக்கும், பட் இது லார்ஜராக இருக்கும். அதனால பெயிண்டிங்க்கு இது செட் ஆகாது. திக் கோட்டிங் வேறு ஃபார்ம் ஆகும். கிறிஸ்டல் சைஸ்லாம் பார்த்தீங்கன்னாக்கா சப்போஸ் ரொம்ப பெருசாக இருக்குது சார், கொஞ்சம் ரெடியூஸ் பண்ணோம் அப்படின்னாக்கா யூ கேன் யூஸ் சர்ஃபேஸ் கண்டிஷனர், அதாவது ப்ரியர் டு பாத், ஃபாஸ்பேட்டிங் பாத், அந்த சொல்யூஷனை யூஸ் பண்ணலாம். ஸோ தட் இட் வில் ரீஃபைன் த கிறிஸ்டல். அதே மாதிரி இது எங்கெங்கெல்லாம் யூஸ் ஆகுது, மெயினாக அந்த ஹெலிகாப்டர், ஏர்க்ராஃப்ட்டு, ஹெவி வெஹிக்கிள் காம்பனன்ட்ஸு, கியர்ஸு, ஸ்டீரிங் பார்ட்ஸு, இந்த இடத்துலலாம் இது யூஸ் ஆகும். அதுக்கப்புறம் இது வந்து ஹை டெம்பரேச்சர் வித்ஸ்டாண்ட் பண்ணக்கூடியது. டார்க் கிரேலேருந்து பிளாக் கலர் அந்த மாதிரி வரும். செமி டெக்கரேட்டிவாக இருக்கும். அதுக்கப்புறம் இமர்ஷன் டைப் ஆஃப் அப்ளிகேஷன் தான் ரொம்ப பாப்புலர். ஏற்கனவே சொன்ன மாதிரி இதில் இந்த கோட்டிங் வந்து திக்காக இருக்கிறதுனால ரொம்ப போராசிட்டி இருக்கும். அதில் அந்த ஆயிலெலாம் உள்ளே போய் லூப்ரிகண்ட்டாக ஒர்க் அவுட் பண்ண ஆரம்பிச்சிடும். ஸோ இந்த மேங்கனீஸ் பாஸ்பேட்டே ஒரு அருமையான லூப்ரிகண்ட்டாக கூட ஒர்க் அவுட் பண்ணலாம். ஓகே. In today's session, I'll be discussing about acids. What is acid? It's a reagent that is capable of giving proton H+. Let us discuss about these acids under various subtopics like sources, then what is the definition of acid, and I'll be explaining about the types of acids, then properties. Whenever you discuss properties, you have to discuss under two headings. One is physical property, another is chemical property. Okay, so physical properties, chemical properties. So naturally, what are the uses of these acids? So under these subheadings, we will be explaining this concept map. Now, when you say sources, for example, apple is the source of malic acid. Lemon contains citric acid. Tomato contains oxalic acid. Grapes contain tartaric acid. Vinegar, that contains acetic acid. Curd, that is nothing but lactic acid. Tea contains tannic acid. And similarly, you have gastric juice. What is gastric juice? It's present in stomach, and that is responsible for digesting your food. So that contains essentially hydrochloric acid. See, our stomach is the acid bag, acid container. And the inner layer of the stomach is called gastric layer. So at the time of hungry or at particular time, whenever you feel hungry, that is because of the juice, gastric juice secreted. That is nothing but hydrochloric acid. So the stomach is ready to digest your food. And that is why in Tamil we used to call it pasittu pusi. Right? So when you feel hungry, you have to take food. And then, let us define acid. Acid, actually it is a Latin word, acidus. Acidus means sour tastes. புளிக்கும் அப்படின்னு சொல்லுவாங்கல்ல, sour tastes. இப்போ லெமன் எடுத்து வாயில் விட்டோம்னு வச்சுக்கோ, என்ன ஆகும்? இல்லை. So, sour tastes. And actually, according to Arrhenius, acid is the one which gives out proton. We call hydrochloric acid, HCl. Why? It releases proton. Okay? You can write later, listen to me. So HCl, that gives out H+, that is proton. And that is why it is an acid. So what is acid according to Arrhenius? It is a reagent that gives out proton. That is H+. Sometimes it will give one proton. In some reagents it gives two protons. So that is H2SO4, sulfuric acid. How many protons are there? Two protons are there. Therefore, it is available as 2 proton. Okay, and that is why based on the, basicity we used to classify. I'll explain later. HCl is called monobasic acid because it gives out one H+. Sulfuric acid is a dibasic acid because it gives out 2 H+. But you cannot go by mere quoting the number of protons available in the acid. Okay, for example, ammonia, that too contains 3 hydrogen, but that is not available for as proton. So you cannot come to a conclusion that all the hydrogen present in a particular compound will be responsible for proton delivery. No. For example, acetic acid, let us consider acetic acid. The formula is CH3COOH. How many hydrogens are available there? 4 hydrogen, is it not? CH3COOH. So you cannot say, sir, that is tetrabasic acid. That is wrong. Because CH3COOH is a weak acid. Almost all organic acids are weak acids. So in the case of acetic acid, actually, that is the CH3COOH, the terminal H which is present in COOH, that is responsible for acidic nature. So it is still monobasic only, even though it contains 4 hydrogen. 3 hydrogens are available along with the C methyl group. So that is not available on ionization. It won't be split up further. But this COOH, that will split and H+ will be isolated. And that is why it is monobasic acid. Okay, right. Then let me talk about the ionization process. So in ionization, that undergoes ionization along with water to give out H3O+. That is called hydronium ion. Naturally, hydrochloric acid on ionization gives H+ plus Cl-, right? But hydrogen chloride as gas, that is not ionic, and that will not answer for our litmus paper. So only the aqueous solution. What do you mean by aqueous solution? The hydrogen chloride dissolved in water. that is called hydrochloric acid solution. So that will undergo ionization to give out H plus and Cl minus. Okay. So this HCl gives H plus Cl minus, but the speed of proton is greater, and that is why along with water, immediately it interacts with water to give out H3O plus. That is called protonated water, and it can also be called hydronium ion. So what is hydronium ion? H3O plus, right? Okay. Then let me talk about the different types of acid here. And moreover, here I have shown HCl plus H2O gives H3O plus and OH minus. Are you able to see? HCl undergoes hydrolysis or reacts with water or ionization to give out H3O plus OH minus ion. Okay, so that OH minus ion is obtained from water, and this is H3O plus. Okay, you cannot argue that, sir, that gives out OH minus ion, so it's a base. No, that is available from water. Okay, so you have to consider only the H3O plus here. Okay, right. Then what about the types of acids? We can classify the acids based on the various types: sources, basicity, ionization, and concentration. Are you able to follow? So based on sources, for example, if it is routed through organic, it is called organic acids. Okay, OC means organic here. IOC, inorganic. So these are all called mineral acids like hydrochloric acid, sulfuric acid, nitric acid, phosphoric acid. These are all called mineral acids. After all, they are all inorganic. Whereas oxalic acid, this tartaric acid, all those available in what? The various natural resources. For example, formica means ant. So in the stings of ants and bees, you have some acid that is called formic acid. Okay, HCOOH. Formica means ant. So that is extracted from, that is available in ants. It doesn't mean that by smashing ants you will get acid. Not like that. It is naturally present. Okay, and that is why that reacts with our protein, and you can see some swelling there when you are bitten by the ants or these bees. Okay, right. And now the sources, according to the, based on the sources, we can have organic acid and inorganic acid. And what about basicity? In basicity, we have monobasic acid. As I already mentioned, when it gives out one H plus, like in this case, HCl gives out H plus, monobasic acid. What about sulfuric acid? There are two hydrogen, so it is capable of giving two H plus, and that's why it's called dibasic acid. Can you get me tribasic acid? Example? Anyone? Phosphoric acid, orthophosphoric acid, H3PO4. You can make a note of it. H3PO4, phosphoric acid. That undergoes what? Ionization to give 3H plus and 1 PO4 3 minus. Okay, 1 PO4 3 minus. That is called phosphate anion, right? Then, and so I hope now I have classified based on the acidity. I mean basicity. You may get confused. What is that? For acid you are talking about basicity. It means with how many bases it can interact. So based on that, okay, based on that we are classifying the acid. Okay, for example, if a hero is capable of fighting with the two villains, okay, so he is dealing with the two villains simultaneously. Our cinema heroes, they can fight even with the n number of villains. Okay, so likewise, an acid can react with one base, monobasic acid, two bases, dibasic acid, three bases, tribasic. I hope now you should be able to understand, because it can react only through H plus. Okay, I'll show that reaction later. And here, let us come. That is based on the ionization. For example, we used to call it electrolyte also. Acid is an electrolyte because it can conduct electricity in the solution form or in the molten form. And they are strong. Strong acid, weak acid. Strong acid means what? It cannot like that. Hydrochloric acid will not show its muscle. Okay, what do you mean by that? It's strong means what? Not by concentration. that is by nature. It has got more corrosive power. It has got greater extent of H plus releasing. That is, they are readily splitting into we call it dissociation or ionization. They undergo readily ionization. When you take a HCl, it becomes what? That is H plus Cl minus. When you take sulfuric acid, H plus 2H plus SO4 2 minus. Likewise, they readily dissociate, and that is why we call it strong acid. And not only that, they completely dissociate. Okay, they completely dissociate. So completely dissociate means when you take nitric acid, it completely dissociates into H plus and the NO3 minus, nitrate anion. Are you able to follow? Right. And similarly, you have what? Weak acid. As an example, acetic acid, organic acids or weak acids. Okay. So CH3COOH is acetic acid. That is a weak acid, right? It means that is they cannot dissociate readily. There will be an incomplete dissociation. The degree of dissociation is less than 1. It means that is slow ionization takes place, and that is why it is weak. Even among our students, some students, they readily undergo changes in the intellectual level by teaching. Is it not? It means what? They can be easily taught. Fire mari patipa. There are some students, they are very dull, and it will be very difficult to deal with them because they are not aware of the basic concepts. Okay, so they are very weak. That is by the nature. Okay, right. And the next one, concentration base. So based on the concentration, we can classify the acid like concentrated and dilute. For example, let us take the same strong acid, hydrochloric acid. When it is diluted with the n amount of volume, n volume of water, it means what? It is less corrosive. It will corrode, but it is not vigorous. So based on the concentration, we can split the acid into what? That is also strong and weak, but we should not use that term. Instead, concentrated acid, diluted acid. Are you able to follow this? Right. So I hope now you are thorough with the types of different acids. Okay. Then let us come back to the properties. Properties we can classify into two major aspects. One is physical property, another is chemical property. Now I have got chalk piece here. I can break this chalk piece. Okay, so when I break the chalk piece, what I have done, is it have I broken any bond between them? I cannot break any chemical bond just by hand. What I have done, I have broken only the physical forces of attraction existing among the molecules. Between the molecules, it is called intermolecular force of attraction. That is Van der Waals force of attraction. That is also called a cohesive force. So I am breaking only the intermolecular force of attraction. So it is only a physical force of attraction. Got it? I can crush into powder. So it may lead to different physical modifications. For example, when I got ice, I can melt it, still it's water. I can further boil, still it's water, but it's steam. Got this point? But when I ionize, when I pass electricity, what happens? It splits into H plus and OH minus ion. That is chemical reaction. So for a chemical reaction, chemical bond should be broken. When I take HCl, I break H plus Cl minus. Can I use the hammer to break the chemical bond? So you cannot achieve by physical means. So by chemical means it is possible. Do you understand this? Right. So here, so the properties associated with the physical bond, when they are broken, you are able to get different properties. For example, melting point, boiling point, these are all physical properties only. You are changing just the physical modifications. Solid to gas, gas to solid, liquid to gas, like that. Okay. And that is why under physical properties, we used to say appearance, whether it is crystalline, solid, non-crystalline, what is the color, right? And how about its coarseness, whether it is a fine powder or coarse powder. Got it? And you can talk about the refractive index. These are all physical properties also. And what about the taste? You are not supposed to taste all chemicals. For example, salt, you can naki pattu, uppu karigide. Tamarind kundu vandu naki pattu, this is acid. But when you take sulfuric acid, naki pattu, this is Sulfuric acid means out. Your tongue will not be there. Okay. So what you are supposed to do, we cannot go everything by oral tests. Okay. So we have got specific solutions, reagents, indicators. So those indicators in the preliminary level, that is, we can use litmus paper. For example, blue litmus, on reaction with acid it becomes red. So blue to red acid. If it is base, you can just inverse it, that's all. So blue to red, you just remember that one. Okay. And it, as I already told you, it can conduct electricity. It will conduct. Okay. And that's why you can have lemon battery also. Just you prick 2 pins and it will start glowing a small lamp. It acts as an small electrolytic cell. Okay. Right. And now let us talk about the chemical properties. So chemical properties, the very basic thing is acid, when it reacts with a metal, it gives a salt and a hydrogen. You take magnesium, and magnesium is a metal, is it not? So that it's called a magnesium. We used to say ribbon, magnesium ribbon. It is very soft, and that reacts with the sulfuric acid to give magnesium sulfate, MgSO4, with the removal of hydrogen. So whenever acid reacts with a metal, hydrogen is removed. So this is a very important point you have to note down. And that is why when you soak any metal for too much time, that will cause lot of hydrogen liberation, that will affect the metal crystal, metal lattice itself. That is called hydrogen embrittlement. That metal will become weak and be broken very easily. So that will affect the basic, the strong nature of metal. Okay, for cleaning purpose, for removing rust, we use some hydrochloric acid, sulfuric acid, but it should not be kept immersed for too much time. Okay, and then acid plus metal carbonate, for example, sodium carbonate, even metal carbonate, bicarbonate, this is called sodium bicarbonate, NaHCO3. So this carbonate will be released as on reaction with HCl or any acid to give out what? Carbon dioxide. So you can have the brisk effervescence of carbon dioxide. Okay, and similarly sodium bicarbonate, that reacts with the hydrochloric acid to give out NaCl, water and carbon dioxide. So carbon dioxide is the brisk evolving of gas is called effervescence. Are you able to follow? Right. You can see the bubbling of this carbon dioxide. And when acid reacts with the metal oxide, it gives metal, salt and water. For example, calcium oxide, that reacts with sulfuric acid to give calcium sulfate and water. Okay. And similarly, let us consider sulfuric acid. It's called the king of chemicals. Okay. So that is used, now I am supposed to talk about the uses. So sulfuric acid is the king of chemicals, and that is used in battery. Then hydrochloric acid is used as a cleansing liquid in toiletries, okay, toilets. Then tartaric acid is used in baking powder, and citric acid, that gives out effervescence, and that is why it is used in baking and as well as in preservative also. Then you have got carbonic acid. For example, you take water and blow it off. When you blow, that water becomes carbonic acid. Do you know why? Because we exhale or we give out carbon dioxide. So carbon dioxide reacts with the water to become carbonic acid. In fact, that is called aerated water, and that is nothing but our cool drinks, is it not? So we use this in aerated drinks, and that is why when you shake, you give the thumbs up, enormous amount of bubbling of water comes out. Soda, we say soda, is it not? Shake pannikkum oru kulu kulu palichinu adikudilla. Then oxalic acid, that cleans the iron stains. Even that is, when you have got any iron stains of a cylinder in kitchen, you can make use of oxalic acid. And even in shirts, when you have got any iron stain, any rusting stain, you can use this oxalic acid to clean it. It will go. Even ink, it will go. And ink smudges can be cleaned with oxalic acid. And then nitric acid, that is used in paint industries, fertilizers, dye industries and drugs. Okay, and so with that we have discussed the entire aspects about the acids, and the last and the important one, it's not the least, it's not, it may be the last one, but it is very very important, that is called aqua regia. So what do you mean by aqua regia? It's called that is king's water, தமிழ்ல ராஜத்ராவகம் சொல்லுவாங்க. For example, hydrochloric acid, nitric acid, so these are all these acids will not react with gold. Gold is a royal metal that will not react, but when you take HCl and HNO3 in 3:1 ratio, that becomes what? Aqua regia, and that will dissolve your gold, so you have to be very careful. Okay, right. I hope I have discussed in detail about this acids part of it, and similarly you should be able to prepare such kind of concept map. So the use of concept map means, that is, you can have the frame memory and instantly you can reproduce anything, and that will be very useful for your examination point of view. Okay, you can collect all these points, something like a magnet, you can catch hold of all those points, you can never miss even a single point here, and develop a mnemonic. For example, what are the important aspects about the acids? One is sources, 2 definition, 3 types, 4 physical property, chemical property, and 5 uses. So these are the major aspects about any chemical. Got it? Right. I hope you should have enjoyed this lecture. If you got any doubt, you can ask me in the comments column. Now I will try to ask you some questions. Can you get me the answer for this? Okay, let us discuss. Try to answer. Take down. You can refer this, and based on that you have to tell me the answer boldly, so that the others should be able to hear your nice voice. Right. What is the Latin word for acid? Anyone?
Acidus.
Very good. Acidus means what?
Sour.
Sour. Very good. Next question. You can make a note of it also when I ask you some questions. Right. And sulfuric acid is a monobasic acid. True or false?
False.
Why?
It is a dibasic acid.
It's a dibasic acid. What is the formula of sulfuric acid?
H2SO4.
H2SO4. That's good. Next. Now I'll give you a reaction. Try to get me the product, and you have to tell me the type of, what type of product I am missing. Take down. Zn plus. Zn means zinc. Zinc plus 2HCl gives zinc chloride plus dash. What is that gas?
Hydrogen.
What is that?
Hydrogen gas.
Hydrogen gas. Correct answer. Then, apple contains malic acid, but what about orange?
Ascorbic acid.
Ascorbic acid, and it's also containing citric acid. Lemon is also having citric acid, but the specialty of orange is it contains both. Ascorbic acid. Orange contains ascorbic acid. Citrus fruits like lemon, that contains
Citric acid.
citric acid. Very good. Blue litmus paper becomes dash when it reacts with what? Acid. Red. What is the formula of zinc sulfate? Anyone? Zinc sulfate. Zinc sulfate. Is that an SO4. That's good. Zn is 2 plus, SO4 2 minus. So Zn SO4. Zinc sulfate. That's correct. Next question. Calcium chloride formula CaCl2. Very good. Calcium chloride CaCl2. The acid secreted in our stomach is dash.
Hydrochloric acid.
Hydrochloric acid. The molar ratio of hydrochloric acid and nitric acid in aqua regia is
3:1.
3:1. Correct answer. Sodium hydroxide is a strong acid. True or false? False. Because that's a base. Sulfuric acid is the dibasic acid. But what about nitric acid? Monobasic acid because HNO3. Good. Can you get me an example of phosphoric acid? I'm sorry, I have told you the answer. Anyway, what kind of acid is phosphoric acid?
Tribasic acid.
Tribasic acid. That's good. Why? What is the formula of phosphoric acid?
H3PO4.
H3PO4. That's good. Correct. Next one. I was explaining about acid and base that gives salt and water. This reaction is called dash.
Neutralization.
Neutralization reaction. When you take any acid, that will react with the base to give salt and water. So this reaction is called neutralization reaction. That's good. What acid is used in aerated drinks?
Carbonic.
Carbonic acid. What is the formula of carbonic acid? Carbon dioxide is CO2. I said carbon dioxide dissolved in water. So you just add it
CO2 plus H2O.
H2CO3. The reactant is H2O and HCO2. When you add H2CO3, write down. So carbonic acid H2CO3. And what is the salt obtained from carbonic acid? There are two types of salt obtained. One is carbonate, another is bicarbonate. Let us consider sodium hydroxide that reacts with H2CO3 so that you are able to get Na2CO3. Got it? So these two hydrogens are replaced. Now tell me what is the compound? Sodium carbonate, Na2CO3. Sodium bicarbonate is nothing but NaHCO3, where one hydrogen is replaced by sodium. And that is why carbonic acid is a dash acid. Is it monobasic, dibasic, tribasic? Dibasic acid. Why? Because it is H2CO3 and both these hydrogens can be replaced by bases, two bases, and that's why it's called dibasic acid. Got it? Right. Next one. Now you have to tell me what type of acid is present in these natural resources. Okay? Right. Apple,
Malic acid.
lemon,
Citric acid.
grape,
Tartaric acid.
tomato,
Oxalic.
vinegar.
Acetic.
Very good. I hope now you have wonderfully followed my lecture. Thank you very much. Hello my dear friends. In this session I'll be explaining about the troubleshooting in phosphating plant. This is one of the important sessions where every phosphators and the technical representatives or technical people, the field people, the engineers, they encounter almost such type of coating defects, especially in phosphating and the powder coating plants. Now, in fact, before starting this training session, I would like to share one important information. See, phosphate coating by itself is not corrosion resistance because it has got some pores. And after all, the even when you take acid that etches the metal substrate and that cleans the rust, that is de-rust, just by etching action only. That is, it removes the oxide layer formed on the metal. When any metal is exposed to water and air, that is oxygen, they are prone to oxidation. So this fine film formation of metal oxide is called rusting. Of course, except royal metals, almost all metals, they have the tendency to undergo oxidation. So this oxidation is called rusting, you know very well, and you have to remove this oxide rust film only by using, suppose if you want to use mechanical means, you can sandblast. If you want to use chemical means, you have to use necessarily acid. And that is why the more rusted particles are de-rusted by using hydrochloric acid or sulfuric acid or phosphoric acid. Of course, phosphoric acid is mild, whereas hydrochloric acid is very strong. When you use such type of mineral acids, heavy acids, you have to use suitable inhibitors. Now, our idea is, that is, when you take any sheet metal, as I already insisted, it should be totally free from oil, grease, rust, dust in any form. So these oil and grease are non-aqueous. That can be removed only by using that is alkaline degreasing or vapor degreasing. And these rust and dust should be cleaned by using acidic media. So alkali media, that is a basic solution, removes the, acidic solution removes the rust. Basic solution, that is alkaline solution, removes the layer of oil or grease. So you have to be very careful about that. So it means we are using both acid and the base in our complete metal pretreatment. Assuming that your product, your component, your raw material, that is sheet metal, is totally free from rust. It contains, definitely it should contain some oil or dirt or grease. Once you have cleaned all these things, before phosphating, you should not use your hands for handling the components. So you have to take care of that one. Suppose if you have used your hands for shifting the cleaned sheet metal, in fact you can find the pattern, the handprint in the phosphate layer also. And that is why, as a virgin metal, that is, it should be treated very, very cleanly, smartly. Okay, so we have to handle the cleaned material before phosphating gently. Try to avoid the human contact. You can make use of proper hoist and jig arrangements so that you can comfortably and conveniently dip or spray with phosphating solution. Now let us go ahead. Suppose if you have got many issues, like, sir, there is a patchy area in the phosphating, and in some area it is not coated properly, and there is a coating, uniformity is not there, and there is some coarseness. So likewise, there are so many problems associated with the phosphate coating. Let us discuss one by one. Now, sir, in my case, that is, coarse crystals are formed. It is very coarse. So when the zinc phosphate coating is a heavier, that is coarser, what will happen? That will reduce the aesthetic value of your finish, and not only that, it will affect the gloss of the paint. and there will be more adsorption. And if there is more absorption means the surface will not be uniform, so the final finish will be affected. So the best thing is if you find such coarse crystals, and not only that, it will affect your salt spray resistance, water resistance, and other dry film properties. So that is why if you find any coarsal crystals, normally it is because of insufficiency of accelerator. What is the accelerator? Accelerator is an oxidizing agent. You have got variety of accelerators. For instance, you have got the sodium nitrate that is built in, and the chlorate is self-oxidizing, and the nitrite is an external accelerator or oxidizer. In fact, the nitrate should be handled very safe, gently, carefully, and it should be mixed only in the bath. You should not previously keep it mixing along with your phosphating solution. That will affect your system. So the best way is you have to keep the nitrite. There is a difference between nitrite and nitrate. Please make a note of it. Nitrite is NaNO2. Nitrate is NaNO3. That is nitrate. So nitrate can be added in the bulk of the solution already when you manufacture this phosphating chemical. But nitrate you should not add along with that system. That should be ideally separately, that is supplied as an accelerator, or some people they call it toner also. Okay, right. So you have to add carefully the accelerator if you feel that the phosphate crystals are coarser. Is it okay? Right. And then patchy coating. Sir, there are some patches, it is not uniform. So in that case, it indicates that your concentration bath, its acidity, total acidity, free acidity, everything has been affected. So you have to take care of the bath parameter, and you have to top up with the phosphate solution, zinc phosphate solution. Actually, that is, it is available in various ways, is a single pack or dual pack, etc. So you have to add necessarily in the given ratio. So you have to add phosphate. Along with that, you have to add accelerator also. Now, sometimes what happen, there won't be any phosphating at all when you start the bath. So in that case, what you are supposed to do, some people, in order to trigger the phosphating, they used to add some iron wool also, iron powders or iron pieces, in order to make the process slightly aggravating, in order to activate, okay. But it may not be required for all cases, but case to case it has to be arrived at, and you should make a proper judgment about that, about adding this iron wool. Next, dark brown. So dark brown bath solution. Sir, my solution has become very dark. Okay, so it is due to excess iron. Okay, so this excess iron should be driven away, and you can add accelerator also. And how I can, otherwise you have to replace the bath. That is the best way. Okay, then if the bath is very old, sometimes such type of problem will arise. So you have to, that is how long you can maintain the bath. So that should be carefully planned, and that is obtained in consultation with your phosphate coating chemical supplier. Okay. Then yellowing means, that is after that is phosphating, there are some yellow patches found on the phosphate layer. So it may be due to what, that is a poor water rinse. They would have not properly rinsed with water. Some people, they simply rinse with water, they don't use DM water. In my opinion, always a phosphating solution should be made up only with the DM water, and after that you have to use only DM water. You should not use normal water for that is a rinsing. That will give you a better performance. And not only that, you should constantly replace that DM water also. And some people, they will have some overflowing arrangement, and they will maintain a constant flowing of DM water. Then when you drag, for instance, assuming that this is the phosphate component, phosphated component. There will be some tricky corners, and sometimes they may catch, okay, in silent corners all these acidic solution. So if it is a trap, probably when it is evaporated, and there will be more concentrated part there in that particular silent corners, and that should be properly removed. So in fact you have to take care of the design aspect also. Otherwise you have to make a jig in such a way that is all the ensure all the rinse solution is drained off. So in such a way the angle, the orientation of the component should be maintained. Then okay, so in that case you have to give good water rinse. Next, improper drainage system. Sometimes there will be a poor drainage system. So in that case you just look at the design of the phosphate bath, and you have to make an arrangement for what, that is make sure of complete drainage of, that is what you call the floating or frothing materials, okay. And then insufficient drain, if it is not, sometimes they most of the people I have seen, they simply keep it under sunlight and they feel that everything has gone off, okay. So better you have to make a hot air movement, at least a hot air blow, and especially as I already suggested in the silent corners where the phosphating solution is caught, okay, right. Then as I already suggested, at least you have to maintain the water, it has to be evaporated between 90 degree and 110 degree. So hot air blow arrangement should be given, okay. So let me continue with the next aspect about the, I will talk exclusively about the oxidizer, okay. Hi friends, thank you for your valuable comments and support for my technical series on metal treatment and metal finishing. Now let me take up a very important session today. This will be very useful for phosphate manufacturing people, the formulators particularly. Technical tips for phosphating formulators. See, first of all, I have already mentioned about the various types of phosphate, that is iron phosphate, zinc phosphate and manganese phosphate. So here we are focusing on zinc phosphate, maybe calcium modified phosphate and trication phosphate also, okay, right. See, essentially a phosphate coating chemical should contain zinc ion, zinc 2 plus, and phosphate, that is PO4 3 minus, phosphate anion. Then nitrate is represented as NO3 minus, nitrate anion. So nitrate we usually take nitrate as sodium nitrate. Then copper ion, nowadays they incorporate copper also. Then fluoride in certain cases. Then nickel, so this will give beautiful greenish color also. And then nitrite, NO2 minus nitrite. So you should be able to distinguish between nitrate and nitrite. Nitrate is sodium nitrate, NaNO3, whereas nitrite is NaNO2, sodium nitrate. So this sodium nitrite should always be given separately and should not be given along with the bulk of the chemical. Then manganese 2 plus, and it may contain a tartrate or citrate and other organic acids. So the very idea is we trigger the phosphate in presence of an acidic condition, acidic medium, and normally we use for instance that is a citric acid, then tartaric acid. So such kind of acids will tune the phosphate crystal patterns also. And sometimes now the latest formulations and advanced formulation, we can say it may contain silico-tungstic acid. Okay, silico-tungstic acid. It means it contains silicic acid as well as tungsten, that is wolfram. Probably that is you have got that element in the bulb, bulb filament. So that is based on wolfram, that is tungsten. So that is known as tungstic acid. And then please note down the quantity I have roughly estimated in terms of gram per liter. For example, zinc 2 plus, you have got it depends because you can change. Actually, that is my idea is most of the people they ask me formula, but in my opinion, with my 35 years experience, I don't want to give the exact formula. Do you know why? Because better learn from me how to formulate. That will be better for you instead of giving one formula. And in fact, you know very well the quality of the product depends on the quality of the inputs, the quality of the raw materials you select. Probably that is you may not know that is the purity of the chemical. And if I give one formula, based on that formula you may work out, and for some clients it works out, some clients it may not work. It is because of the purity of the chemical also. Okay, so when you I think that is in my opinion, if you want my consultancy, I don't give exactly the same formula, and it has to be mended. See, that is, it has to be customized. So if you learn from me how to formulate, that would be better. Okay, so I'll let you know all this chemistry behind the formulation of all these chemicals. Okay, right. So here silico tungstic acid, it ranges from before that I want to tell something about the zinc 2 plus. So make sure your chemical should not exceed 20 gram per liter. Suppose if you take 1 liter chemical, and the zinc content should not exceed 20 gram. Okay, so there are some tolerance values, and you should try to understand the basic chemistry about that. You cannot go on adding that is a zinc in order to get better performance. If you see, sometimes we used to say in Tamil, amardamum minjinal visham. It means that is when it let it be that is amrita, it should not exceed. Is it not? It may be a universal medicine, but there is a limitation for that. Okay, so it is called a lethal dose in English. Lethal dose. It will be lethal. Even it may be a curative medicine, but it should not cross the limit. So similarly here, that is when you take the zinc 2 plus ion, and it is permissible between 2 grams to 20 gram. Do you understand this? Right. And when you take this zinc, and what about the phosphoric acid? Where from you get the phosphoric acid? For example, you know very well, zinc is there, phosphoric acid is there. When you combine these two, it forms zinc phosphate. This is a simple thing. But I will tell you that it's not secret. It is the basic chemistry of coating formation with the help of zinc phosphate. Okay, so I'll deal with that in my subsequent classes. Now, so here zinc as a zinc oxide. Remember, zinc as a zinc oxide. The zinc oxide is a powder, white powder, where the zinc content should be 2 to 20 gram. Clear? And phosphate means that the amount of phosphate. So it in terms of phosphoric acid. So it is given as H3PO4. So when it take phosphate means it represents phosphoric acid, and that content should not exceed 40 gram. That is 5 to 40. So the same proportion should be maintained. Almost 1:2 proportion should be maintained. Then silico tungstic acid. So this is one of the accelerators actually. So, and here you can have the maximum dosage of 0.05 to 2. And you have manganese, and manganese, this is 2 gram per liter. Then citric or manganese ion, then citric or lactic or tartaric acids. Okay, and glycerophosphoric acid, and it's a salt. So you have to take, you cannot take all together. You have to consider only one that is accelerator, one oxidizer. Oxidizer is nothing but oxidizing agent, that's all. That increases the speed of the reaction, and especially this nitrite that tunes the fine crystal nature of the zinc phosphate. And let me come back here, and I have noted down the maximum load also, 0.1 to 1 gram per liter. And then, so these are all with regard to that is mild steel. Suppose if your client is interested in developing a coating zinc phosphate coating chemical for galvanized iron. Okay, so you have to slightly change the formula. So here for GA, it is my humble suggestion that it should be chlorate free. If it is GA, it should be chlorate free. It means that is you should not put chlorate in your formula. You can replace this with nitrite. Okay, so here we have got zinc 2 plus and the load is 0.1 to 1.5 gram only. Okay, so you can find the difference between the ordinary, the mild steel and the galvanized iron. So here we have got a 2 to 20 gram, whereas you cannot exceed here 1.5 gram per liter as far as GA is concerned. So the zinc load should be, because it's already galvanized, is it not? So you cannot load further. So zinc 2 plus should be between 0.1 to 1.5 gram per liter. And phosphate also, that is 5 to 50 gram per liter. And manganese 2 plus 0.2 to 4 gram per liter. Then chloride ion can be 0.05 to 0.5. So these are all the tentative formula, and as I already suggested, you have to supply the accelerator always as a separate pack. So here the accelerator nitrite 0.1 to 0.2 gram per liter. You can beautifully work out this formula. You take simply sodium nitrite and dissolve it. So if you take 1 liter, okay, the content should be, nitrite should be 0.1 gram to 0.2 gram. It's a very simple formula. You can easily do it. Okay, and then nitrate should be how much? 1 to 10 gram per liter, or you can add 100%. Some people they take hydrogen peroxide also, but in the pure form. But in my suggestion, that is sometimes it is not stable, so I won't suggest hydrogen peroxide. In my practical experience I have seen. Then, but these are all one of the formulations. In certain countries, in certain places, it may work out. And there are some specific accelerators like meta-nitrobenzene sulfonate. Please make a note of it. Meta-nitrobenzene sulfonate. Actually, this is based on petrochemical products. That is a benzene, you know very well, C6H6, benzene sulfonic acid. And in benzene sulfonic acid, nitro group is attached in the meta position. So it's called meta-nitrobenzene sulfonate. Okay, so here you can take 0.05 to 2 gram per liter, and similarly meta-nitrobenzoate can be added. Okay, meta-nitrobenzoate, and similarly you can have para-nitrophenol also. Okay, now many guys, they are very much interested in taking advantage of cold phosphating. For cold phosphating, I think that is you can have PEI. Please make a note of it. PEI. So PEI means polyethylene imine. Polyethylene imine. So this is one of the very good reagent for cold phosphate, I can suggest. And then suppose if the pH of the bath is 2, then my recommendation is you can go for chlorate or nitrite. Suppose pH is 5, almost in the less acidic. In that case, you can use nitrite or hydrogen peroxide. Okay, so likewise we have variety of chemical formulations, but all are based on the substrate where you are going to apply. Okay, and also check the hardness of water. Always make use of DM water or industrial water or potable water for your formulations. Okay, so thank you very much for watching this video. I will continue other important points in my next lecture. Hi friends, இன்னைக்கு இந்த phosphate chemical coating formulate பண்ணுறவங்களுக்கான ஒரு முக்கியமான கிளாஸாக நீங்கள் எடுத்துக்கலாம். இந்த ஃபார்முலேஷனில் எப்படி பண்ணுறது, அதில் என்னென்ன இன்க்ரீடியன்ட்ஸ் இருக்குது. ஸோ இந்த கிளாஸ் ஃபார்முலேட்டர்ஸ்க்கு யூஸ் ஆகும். அதே மாதிரி ஃபாஸ்ஃபேட் ப்ரீட்ரீட்மெண்ட் பிளான்ட்டு வச்சுருக்கவங்க, அதில் ஒர்க் பண்ணுறவங்க, அவங்களும் தெரிஞ்சுக்கலாம் அதில். சரியா? Now, technical tips for phosphating formulators. ஒரு ஜிங்க் ஃபாஸ்ஃபேட் கோட்டிங் அப்படின்னா என்னென்னலாம் அயான்ஸு அதில் இருக்கும் அப்படிங்கிறத பற்றி நம்ம பேசுகிறோம். இதில் Zn2+, அதாவது ஜிங்க் அயான் இருக்கும், பாஸ்பேட் PO4 3-, நைட்ரேட் NO3-, காப்பர் Cu2+, ஃப்ளூரைடு, நிக்கல், நைட்ரைட், மேங்கனீஸ், டார்ட்ரேட் ஆர் சிட்ரேட், இந்த மாதிரியான இன்க்ரீடியன்ஸு மெயினாக இருக்கும். இதுதான் ஃபாஸ்பேட் கோட்டிங்கில் இருக்கிறது. இப்போது இதில் எந்தெந்த கெமிக்கல் எந்தெந்த அளவுக்கு இருக்கும் அப்படிங்கிறத பற்றி பார்ப்போம். Zn2+ பார்த்தீங்கன்னாக்கா 1 லிட்டர் எடுத்திங்கன்னா 2லேருந்து 20 கிராம் வரையில் இருக்கலாம். சரியா? அடுத்தது பாஸ்பேட் ஆனையான். அது எப்படி இருக்குன்னா, பாஸ்பேட்னு இந்த இடத்துல பாஸ்பாரிக் ஆசிட், சரிங்களா? அங்கேருந்து வர்றது தான் பாஸ்பேட். ஸோ அந்த பாஸ்பேட் அதில் 5லேருந்து கிட்டத்தட்ட ஒரு 40 கிராம் வரையில் இருக்கலாம் 1 லிட்டரில். அதுக்கப்புறம் சிலிக்கோ டங்ஸ்டிக் ஆசிட் இல்லாட்டினா மேங்கனீஸ், அதுக்கப்புறம் சிட்ரிக்கு, லாக்டிக்கு ஆர் டாட்டாரிக் ஆசிட் ஆர் கிளிசரோஃபாஸ்பாரிக் ஆசிட் ஆர் இட்ஸ் சால்ட், இந்த மாதிரியானதெல்லாம் ஆக்சலரேட்டராக யூஸ் ஆகும். இது வந்து எவ்வளோ இருக்கலாம் அப்படின்னா 0.005லேருந்து 2 கிராம் வரையில் இருக்கலாம் 1 லிட்டரில். அதே மாதிரி 0.1லேருந்து 1 கிராம் இருக்கலாம். இதெல்லாம் ஆக்சலரேட்டராக யூஸ் ஆகுது. ஆக்சலரேட்டரோட ரோல் என்னென்னா, இந்த ஃபாஸ்பேட் கோட்டிங்கை யூனிஃபார்மாக மாற்றும், குயிக்காக டெபாசிட் பண்ண வைக்கும் அந்த மெட்டலில். அதுக்கடுத்தது சப்போஸ் இப்போ நம்ம ட்ரீட் பண்ண வேண்டியது, இதெல்லாம் மைல்டு ஸ்டீலுக்கான ஃபார்முலா. ட்ரீட் பண்ண வேண்டிய மெட்டீரியல் வந்து ஏற்கனவே அதில் ஜிங்க் கண்டென்ட் இருக்குது, அதாவது கேல்வனைஸ்டு கோட்டிங் இருந்தது, கேல்வனைஸ்டு அயானாக இருந்ததுன்னா அந்த இடத்துல நம்ம ஜிங்கோட அளவை கம்மி பண்ணிக்கணும். ஸோ அப்போது ஜிங்க் வந்து 0.1லேருந்து 1.5 கிராம் பர் லிட்டர். இப்போ மைல்ட் ஸ்டீல் எடுத்திங்கன்னா இங்கே 2லேருந்து 20 கிராம் வரையில் போகும், ஆனால் அதில் வந்து கம்மியாக தான் இருக்கும். அதுக்கடுத்து 0.1 to 1.5 ரொம்ப ரொம்ப கம்மியாக இருக்கும். அதுக்கு தகுந்த மாதிரியாக பாஸ்பேட் வந்து பார்த்திங்க அப்படின்னா 5லேருந்து 50 கிராம் வரலாம். தென் மேங்கனீஸை பொறுத்த வரையிலும் 0.2லேருந்து 4 இருக்கலாம், 4 கிராம் பர் லிட்டர். குளோரைட் அயான்ஸ் அதில் இருக்கலாம். ஆனால் இதில் முக்கியமாக ஒரு விஷயம் தெரிஞ்சுக்கணும், இதில் எப்போதுமே குளோரேட்டுன்றது ஒரு செல்ஃப் ஆக்சலரேட்டிங்காக இருக்கும், ஆனால் அதை வந்து ஜிஐயில் யூஸ் பண்ணக்கூடாது. அதுக்கு அடுத்தது ஆக்சலரேட்டர் அப்படிங்கிறப்போ இங்கே நைட்ரைட், அது ஒரு ஆக்சலரேட்டராக வரலாம், நைட்ரேட் வரலாம், ஹைட்ரஜன் பெராக்சைடு 100% வரலாம். இது எல்லாமே ரேஞ்சு 0.1லேருந்து 0.2, 1லேருந்து 10 கிராம், அதுக்கப்புறம் 0.5லேருந்து 5 கிராம் பர் லிட்டர், இந்த மாதிரி இருக்கும். அதுக்கப்புறம் சில ஆர்கானிக் சால்ட்ஸ் எல்லாம் ஸ்பெசிஃபிக்காக இப்போலாம் அட்வான்ஸ்டு ஃபார்முலாவில் யூஸ் பண்ணுறாங்க. ஃபார் எக்ஸாம்பிள் மெட்டா நைட்ரோ பென்சின் சல்ஃபோனேட், அதாவது பென்சின் சல்ஃபோனிக் ஆசிட்னு இருக்கும், அதனுடைய சால்ட்டு தான் பென்சின் சல்ஃபோனேட். அதில் வந்து மெட்டா பொசிஷனில் நைட்ரோ குரூப் இருக்கும், அது மெட்டா நைட்ரோ பென்சின் சல்ஃபோனேட். அதுக்கப்புறம் பேராநைட்ரோ ஃபீனால், அப்புறம் மெட்டா நைட்ரோ பென்சுவைட், இந்த மாதிரியான ஆர்கானிக் பேஸ்டு சால்ட்ஸும் ஆக்சலரேட்டராக போடுறாங்க. அது வந்து எவ்வளோ இருக்குன்னா 0.05லேருந்து 2 கிராம் வரையிலும் பர் லிட்டர் இருக்கலாம். இதெல்லாம் தான் ஒரு ஃபார்முலேஷன். இப்போது சில பேருக்கு வந்து இந்த கோல்டு ஃபாஸ்பேட் பண்ணணும்னு ஆசையாக இருக்கும். ஆசைன்னு இல்லை, அதாவது டெம்பரேச்சர் அவாய்ட் பண்ணணும்னு பார்ப்பாங்க. ஆனால் அது வந்து லாங்கர் டியூரேஷன் இருக்கும். சில இது 1/2 மணி நேரம், சில இது 1 மணி நேரம் கழிச்சு தான் வரும். அது ஏஜ் ஆயிடுச்சுனாக்கா அவங்க சரியாக கோல்டு ஃபாஸ்பேட்டில் ஒரு அலட்சியம் இருக்கும். அதனால தான் நான் ஜென்ரலாக கோல்டு ஃபாஸ்பேட்டை சஜஸ்ட் பண்ணுறதே கிடையாது. இதில் என்னென்னா இந்த PEI அப்படின்னு சொல்லுவாங்க, பாலி எத்திலீன் இமைன், அதுதான் ஒரு முக்கியமான இன்க்ரீடியன்ட் இங்கே. இந்த இது கோல்டு ஃபாஸ்டில் யூஸ் பண்ணுறாங்க. அதுக்கப்புறம் pH2 இருந்ததுன்னா, அதாவது ரொம்ப அசிட்டிக்காக ஒரு பாத் இருந்ததுன்னா அதுக்கு தகுந்த ஒரு, அதாவது ஆக்சலேட்டர் சொல்லினாக்கா we can go for perchlorate or nitrite, அந்த மாதிரி ஃபார்முலா போடலாம். இல்லாட்டா pH5 இருந்ததுனாக்கா ஹைட்ரஜன் பெராக்சைடு இல்லாட்டினா நைட்ரைட் அயான், அதை பேஸ் பண்ணி போகலாம். ஸோ இதுதாங்க தட் இஸ் ஜிங்க் ஃபாஸ்பேட்டு ஒரு ஃபார்முலா எப்படி பண்ணுறாங்க. யூஸ்வலாக வந்து என்கிட்ட வந்து கேட்பாங்க, சார் ஃபார்முலா கொடுங்க அப்படின்னா. நம்ம ஒரு ஃபார்முலா எழுதி கொடுத்தா ப்ரிஸ்கிரிப்ஷன் மாதிரி தானே, ஏதாவது ஒரு இது வந்து ஒரு மெடிசன் மாதிரி எல்லாருக்கும் யூனிவர்சல் ஃபார்முலா, யூனிவர்சல் மெடிசன்லாம் கிடையாது. நம்ம ஒரு ஃபார்முலா எழுதி கொடுத்தோம் அப்படின்னாக்கா நம்ம அதுக்கான கெமிக்கல் கன்ஸ்டியூஷன் பேலன்சிங்கில் பண்ணிக்கிட்டு தான் கொடுக்குறோம். ஃபார்முலாக்குன்னு ஒரு மெத்தட் இருக்குது. ஸோ அப்படி கொடுக்குறப்ப அந்த ஸ்டாண்டர்ட் ஃபார்முலா அவங்க கெமிஸ்ட்ரியை பற்றி பேக்ரவுண்ட் இல்லாமல் இருக்கும். அதனால தான் நான் இப்போ வந்து அதிகமாக கெமிஸ்ட்ரியை பேஸ் பண்ணியே ஒரு ட்ரைனிங் இருந்ததுன்னா அவங்களே ஃபார்முலேட்டன் ஏன் வருது, ஒரு ஃபார்முலா எடுக்கிறோன்னா ஏன் வருது, எதனால் வருது அப்படின்னு தெரிஞ்சுக்கிட்டால் அதை ரீப்ளேஸ் பண்ணுறதுன்றது கொஞ்சம் கம்ஃபர்டபுளாக இருக்கும். இல்லாட்டினாக்கா ட்ரையல் அண்ட் எரர் தான் பண்ணி அதில் வந்து நிறைய மெட்டீரியலையும் டயத்தையும் பணத்தையும் நம்ம வேஸ்ட் பண்ணுவோம். ஸோ பெஸ்ட்டு வந்து என்னென்னா ஃபார்முலா வாங்கிட்டு போய் நான் ப்ரொடக்ஷன் பண்ணுறேன் அப்படிங்கிறத விட ஃபார்முலேஷன் எப்படி போடுறதுன்னு நீங்கள் கற்றுக்கிட்டீங்க அப்படின்னாக்கா அது சொல்கிறதுக்கு தான் இப்போல்லாம் ஆள் கிடையாது. அதனால் எங்களுடைய ஆல்மோஸ்ட் நாங்கள் ஒரு 35 வருஷம் போல் இதிலேயே உழண்டிருக்கோன்றதுனால அதில் நூக் அண்ட் கார்னர் தெரிஞ்சு வச்சுருக்கோம். ஸோ எங்கிற மாதிரி ஆட்கள் நிறைய பேர் இருப்பாங்க. ஸோ அவங்கள்ட்டெல்லாம் நீங்கள் கொஞ்சம் நீங்கள் ஒரு ட்ரைனிங் மாதிரி தான் நீங்கள் போகணுமே ஒழிய சும்மா ஃபார்முலா கொடுங்க நான் போட்டேன். சில பேர் குறை சொல்லுவாங்க, சார் உங்கள் ஃபார்முலா ஒன்றும் ஒர்க் அவுட்டே ஆகலை அப்படின்ட்டு. அது காரணம் 1000 இருக்கும். ஏன்னா அதாவது ரா மெட்டீரியல் சப்ளையர் வந்து என்ன பண்ணுவோம், நம்ம உடனே கேட்பாங்க நம்மள்ட்ட ரா மெட்டீரியல் சப்ளையர் சஜஸ்ட் பண்ணுங்கன்ட்டு. நம்ம ஒருத்தரை போட்டு கொடுத்தோம்னாக்கா அவங்க டீலிங்ஸ்லாம் என்னன்றது தெரியாது. ஏன்னா முக்கால்வாசி ரா மெட்டீரியல் எல்லாமே வியாபார சிந்தனை தானே இருக்குது. எப்படி போட்டு எப்படி பணத்தை வாங்கலாம் அப்படி தான் பார்க்குறாங்க ஒழிய ஒரு தர்மம், அதாவது வியாபாரத்துலேயும் வந்து ஒரு நீதி இருக்கணும். ஸோ அதை எத்திக்ஸை வந்து நம்ம பிஸ்னஸ் எத்திக்ஸை சரியாக கடைபிடிக்கிறது இல்லை. அதனால் நம்ம என்ன பண்ணுவோம், அவன் ஒரு ஃபார்மில் கொடுத்து, சார் அவரெல்லாம் கெமிஸ்டெல்லாம் ஒரு 1000 பேசுவாருங்க, அவர் பேச்செல்லாம் அதெல்லாம் சரிப்பட்டு வராது, நீங்கள் அவர் பண்ணுறதெல்லாம் பார்த்தீங்கன்னா செம காஸ்ட்லி ஆகிடும் அப்படின்னு சொல்லுவாங்க. ஆனால் ஒன்று நல்லா தெரிஞ்சுங்க, நம்மள்கிட்ட பைசா கொடுத்து நம்மள்கிட்ட கஸ்டமர் வந்து வாங்குறாங்க அப்படின்னா அது குவாலிட்டியாக தான் இருக்கணும். புரியுதுங்களா? இப்போது நான் ஒரு சின்ன ஒரு கதை மாதிரி சொல்கிறேன் பாருங்கள். அதாவது ஒரிஜினலாக சிமெண்ட் பெயிண்ட்டுன்னு இருந்தது. இந்த சிமெண்ட் பெயிண்ட்டில் வந்து ஒயிட் சிமெண்ட் வந்து கிட்டத்தட்ட ஒரு 50% to 60% வரையிலும் போடணும். அதுதான் ஒரிஜினல் செம் அப்படின்னு இருந்தது. ஆனால் சில இடைத்தரகர்கள், சில அதாவது வியாபாரத்திலே புல்லுரிகள்லாம் இருக்காங்கல்ல, அவங்க வந்து ஒயிட் சிமெண்ட்டோட கணக்கு, அதுதான் மெயின் இன்க்ரீடியண்ட்டு ஒயிட் சிமெண்ட்டு, அதை கலரிங் ஏஜென்ட்ஸ் எல்லாம் போட்டு அதுக்கு அடிட்டிவ்ஸ்லாம் போடுறோம். அப்போ உங்களுக்கே தெரியும் அதுதான் மேஜர் இன்க்ரீடியண்ட்டு. இதில் என்ன பண்ணுவாங்க, சுண்ணாம்பெல்லாம் போட்டுட்டு கொஞ்சோண்டு 10% ஒயிட் சிமெண்ட்டை போட்டுட்டு நானும் சிமெண்ட் பெயிண்ட்டு விற்கிறேன் அப்படின்னு பேர் வழி பண்ணி தான் இப்போ என்ன ஆயிடுச்சுன்னா சிமெண்ட் பெயிண்ட்டோட பேரே கெடுத்துட்டாங்க. ஆக்சுவலாக ஒரு காலத்துலலாம் நாங்கள் வந்து தட் இஸ் ஒரிஜினல் ஆஸ்திரேலியன் ஃபார்முலாலாம் யூஸ் பண்ணியிருக்கோம். அதெல்லாம் பார்த்தா அற்புதமான ஒரு ஃபார்முலா. நான் அது சில இடத்துல எங்கள் வீட்டிலே அடிச்சிருந்ததெல்லாம் இன்னும் அப்படியே 20, 30, 25 வருஷம் கழிச்சும் அப்படியே இருக்குது. அதுக்கு காரணம் என்னென்னா அந்த ஒரிஜினல் ஃபார்முலேஷன் தான். புரியுதுங்களா? நான் இது வந்து ஒரு பப்ளிக் பிளாட்ஃபார்ம்ன்றதுனால என்னால் அந்த ட்ரேட் நேம்லாம் சொல்ல முடியல. பட் அதெல்லாம் ஒரிஜினல் ஃபார்முலா. அந்த பேஸ் பண்ணி இப்போ எங்களுடைய பஸ் கிரீன் வந்து பார்த்திங்கன்னா உங்களுக்கே தெரியும். அதான் அந்த காலத்து பஸ் கிரீன் அப்படிங்கிறது அடிச்சிக்க முடியாத ஒரு கலர். கோல்டன் ப்ரௌன்றது சூப்பர் கலர். நியூ ஃபிரோசா ப்ளூ, ஸ்பெஷல் ஃபிரோசா ப்ளூ, அதே மாதிரி இந்த கேட்டபிளா எல்லோ, இதெல்லாம் வந்து நாங்கள் சாதித்தது மலையளவுன்னு சொல்லலாம். அந்த அளவுக்கு அதில் 1000 பிரச்சனை வந்தாலும் அதுலேருந்து எப்படி வெளியில் வருது இந்த டெக்னிக்கும் எங்களுக்கு தெரியும். அந்த மாதிரி ஒரு டீப் நாலேஜ் அதில் இருக்குது. அந்த மாதிரி ஃபார்முலேஷன், ஒரிஜினல் ஃபார்முலேஷனோட நாம் வந்து ஒரு இதை பண்ணுறப்போ அது வந்து சக்ஸஸ்ஃபுல்லாக வரும். ஆனால் இந்த ரா மெட்டீரியல் சப்ளையர்ஸ்லாம் என்ன பண்ணுவாங்கன்னா அதோட அதாவது தட் இஸ் இது அவங்களே ஒரு சஜஸ்டிவாக ஏதாவது பண்ணி விட்ருவாங்க. அப்போ நம்மளுடைய ஃபார்முலாவில் அவங்க உள்ளே வந்து டேம்பர் பண்ணி கெடுத்து குடிச்சவராக்கி ஒரு வழி பண்ணிவிடுவாங்க. அப்போ என்ன ஆகிடுன்னா நம்மள்கிட்ட சில சப்ஸ்டியூஷன்லாம் சொல்லவே மாட்டாங்க. சொன்னால் இவர் சார் கோச்சிப்பார் அப்படின்ற மாதிரி அவங்க நினச்சிப்பாங்க. அதனால் கேட்டால் அதுக்கப்புறம் நம்ம அப்படியே ஆராய்ஞ்சு பார்த்தா தான் தெரியும் என்ன ஃபெயிலியர் வந்திருக்குன்றது. ஸோ அதனால் ஆஃப்லைட் எங்களுக்கே ஒரு டயர்டாகி போச்சு. ஃபார்முலா கொடுத்துட்டு அவன் ப்ரொடக்ஷன் பண்ணி அதுலேருந்து அவங்களாம் மாற்று மருந்து கண்டுபிடிக்கிறேன்னு சொல்லி ஏடாகூடமாக பண்ணிவிட்டு அதோட தரத்தையே தாழ்த்திடுறாங்க. சில இதுக்கெல்லாம் ஸ்டாண்டர்ட் ஃபார்முலா மாற்றவே கூடாது. அது காஸ்ட்டுன்னு அந்த காஸ்ட்டை தான் வைக்கணும் இல்லையா? ஸோ அதில் நம்ம ரீப்ளேஸ் பண்ணுறதா இருந்தால் இப்போ டால்டா நெய்க்கு பதில் டால்டா யூஸ் பண்ணலாம். உங்களுக்கே தெரியும் நெய்யில் சுட்ட தின்பண்டமும் டால்டாவில் பண்ணதும் நிறைய வித்தியாசம் இருக்க தானே செய்யும். அதனால் ஒரிஜினல் ஃபார்முலா தான். அதில் எந்த சேஞ்சஸும் தேவையில்லாமல் பண்ணவே கூடாது. இன்றைக்கி கிடைக்குதேன்னு சொல்லிட்டு சப்ஸ்டியூஷன் பண்ணிங்கன்னாக்கா நம்ம வந்து இது கெமிஸ்ட்ரி, இது நல்லா ஞாபகம் வச்சுங்க. இப்போ a+b² = a² + 2ab + b² மேக்ஸு. ஆனால் கெமிஸ்ட்ரியில் வந்து ஒரு சோடியம் ஹைட்ராக்சைடும் ஹைட்ரோக்ளோரிக் ஆசிடும் எப்படி ஜாயின் பண்ணுது, அது எப்படி ப்ராடக்ட் சோடியம் குளோரைடு அண்ட் வாட்டர் கொடுக்குது அப்படிங்கிறத, அது என்ன நடக்குது கெமிஸ்ட்ரியில் நேச்சுரலாக என்ன நடக்குது அப்படிங்கிறத வச்சு தான் நம்ம வந்து சொல்கிறோம், ஒரு இன்ஃபரன்ஸ் கொடுக்குறோம். புரியுதுங்களா? நம்ம சொல்கிறபடி அது கேட்காது. அது எப்படி சொல்லுதோ இந்த டேமிங் த லைன் மாதிரி இதெல்லாம் பஞ்சபூதங்கள் தானே, ரசாயனங்கிறதே இது தானே. அப்போது அது எப்படியெல்லாம் பிஹேவ் பண்ணுறோம் அதை பேஸ் பண்ணி தான் நம்ம பண்ணுறோம். அதே மாதிரி ஃபார்முலாவில் உள்ள பூந்தெல்லாம் ஒன்றும் பார்க்க முடியாது இல்லையா? இதை ரீப்ளேஸ் பண்ணால் வெளியில் தெரியாது. ஆனால் உள்ளே என்னென்ன வில்லங்கம் பண்ணுறோம் அப்படிங்கிறது ஆஸ் அ கெமிஸ்ட்ரி எங்களுக்கு தெரியும். மைக்ரோஸ்கோபிக் லெவலில் அது வந்து என்னன்றது நம்மளால் மெக்கானிசம் மூலியமாக நம்ம கண்டுபிடிச்சிட முடியும். பட் அது கூட வித் அவர் லிமிட்டட் கெப்பாசிட்டி ஆஃப் அவர் நாலேஜ் தான் நம்ம பண்ணுறோம். சரிங்களா? அதனால் ஸ்டாண்டர்ட் ஃபார்முலா அப்படின்றது ஒன்று. இன்னொன்று என்னென்னா ஃபார்முலாவை எப்படி ஓரளவுக்கு நாம் மென் பண்ணலாம் அப்படின்றதும் தெரிஞ்சு வச்சுருக்கணும். அது ஸோ இதுக்கு தான் உங்களுக்கு வந்து ஒரு ப்ராப்பர் ட்ரைனிங் அப்படின்றது தேவை. என்னால் முடிஞ்ச வரையிலும் எனக்கு என்னுடைய எக்ஸ்பீரியன்ஸில் என்னென்னலாம் எனக்கு தெரியுது அப்படிங்கிறதோ அதெல்லாம் உங்களுக்கு இந்த வீடியோ மூலிமா நான் அர்ப்பணிக்கிறேன். இது உங்களுக்கு ரொம்ப யூஸ்ஃபுல்லாக இருக்கும்னு நம்புகிறேன். தேங்க்யூ வெரி மச். Hi friends, how are you? Welcome to my technical series. In today's session, I'll be explaining about accelerators in phosphate coatings. This is a very important topic, and you kindly please make note of this lecture. Here, first of all, let us discuss about what accelerator is. Accelerator is the additive which are added in very small quantity to promote the reaction, to enhance the reaction. The opposite term for the accelerator is inhibitor, that arrests the reaction, that decelerates the reaction. So we have now two terms. One is accelerator, another is decelerator, that is inhibitor. The accelerator encourages the reaction, it enhances the reaction without involving in the reaction. That is very, very important. That is, it won't go inside the reaction and get destroyed by themselves. Not like that. Its presence it is something like a guru or teacher, or like me also. So that is, we don't involve too much in the business process, but at the same time, that is, you can make use of us to accelerate your technical knowledge and thereby your business activities. Here, whatever the product we want to have should be flawless. The best quality products will definitely get good customers. So this is a very important one. And not only that, the way you present the product or the subject or the service is also very important. Let me take up this accelerator. Accelerator, actually, it is an oxidizer, as well as this zinc coating or zinc phosphating or calcium modified zinc phosphating or trication phosphating or manganese phosphating or iron phosphating. So you can call any type of phosphating where these oxidizers are very, very important. Okay, right. So this oxidizer, what is the role? It is nothing but an oxidizing agent. Truly speaking, an oxidizer that undergoes reduction. First of all, let me try to explain further, that is more on the subject oxidation and reduction. Oxidation is nothing but addition of oxygen. For example, you have iron. Iron becomes iron oxide. That is, a metal becomes metal oxide. Actually, it is a process of rusting. Then why should I care about this rusting? Please believe that rust itself is a protective layer, and like in the case of zinc, that is, it is a sacrificial protection. So, for example, we call anodization of aluminium. See, this anodization is nothing but formation of oxide layer over aluminium. So, once the aluminium oxide layer is formed, further oxidation will not take place. Are you able to understand this important point? Okay. See, only the virgin surfaces, the virgin persons, they are subject to any kind of evil attack. Is it not? So, something like that. So, similarly, these oxidizing agents, they help in oxidizing other metals. Do you understand this? And in fact, oxidation is an electropositive behavior. Actually, that is, a metal undergoes oxidation because of its electropositive nature. What is electropositivity? The electron releasing tendency. That is the very behavior of any metal. So the metal that becomes metal oxide, the very tendency, actually we call it rusting. Okay, we don't want rusting, but when we accept that rusting by ourselves, then it becomes a protective layer. So that is the strategy here. Do you understand? For example, we take iron oxide, ferrous oxide, ferric oxide, etc. All these oxides are put together as a iron oxide pigment. Then we apply red oxide paint. What is that? Which is nothing but iron oxide, is it not? Right. Similarly, we want to oxidize the virgin surface of the metal into metal oxide, but at the same time it should be adherent. That is very important. So in the case of phosphate, it is called a metal phosphate. And with all that, we take some efficient metals also, like zinc metal. Along with that zinc metal, manganese, and you can take nickel also. In fact, if you have got the phosphate of zinc, manganese, nickel, we call it a trication phosphate, which is supposed to be one of the best phosphating systems. And we have got calcium modified zinc phosphate also. And nowadays we talk about the zirconium oxide, that is the nano ceramic coating, nano zirconium oxide. Okay, zirconium oxide. So we have got nano level, that is it can protect in the nano level. So the technology is totally different. Now let me talk about, I think I have given a separate video about this nano coating. You can watch that video. Now let me confine to the zinc phosphating or phosphating generally. So we use this accelerator as a separate pack, that is always advisable. Because that is, it will not lose its nature, and at the same time, that is keeping in the storage, that is, it should not get decomposed, and it will react to some other reactions also. So that is, we should not cause any disturbance to the existing system. So that is why we give this as a 2-pack system. So please remember, especially nitrate, that should be supplied separately only. Okay, right. Now let me talk about the variety of accelerators, that is oxidizing agent. And I wanted to share some more knowledge about the oxidation. So oxidation is nothing but addition of oxygen, removal of hydrogen, then de-electronation, that is the removal of electron. Okay, and then that is increase of oxidation number. So in various ways we can remember this oxidation. I will tell you some mnemonic which is called, we used to say Leo Gur, Leo L-E-O, Gur. See, when the lion, that is it roars, Gur, so like that. Okay, so Leo Gur, Leo L-E-O, loss of electron is oxidation. Gain of electron, Gur, gain of electron is reduction. Simply you can remember. And similarly, oil, rig, that is oxidation is loss of electron. Rig, reduction is gain of electron. Like that you can remember. So these are all the various memory techniques we adopt. Anyway, let me come back to the subject. Now we are talking about oxidizing agent. See, if you want to get the oxidation and enhance that oxidation process, you have to add this oxidizing agent. And what is this oxidizing agent? Actually, that gives the oxygen. When an agent supplies oxygen, it is a loss to that, is it not? So that means it undergoes reduction. So you please remember that. Okay, an oxidizing agent undergoes reduction. Got it? Okay, right. Then, now let me come back. Here I have written various oxidizing agents, that is accelerators. Nitrite, it is given by NO2 minus, nitrite, that is called nitrite. So if you want to choose a nitrite as an oxidizing agent, remember you should have the ratio 0.1 to 0.25 gram per liter. That should be the concentration you have to maintain. Okay. And then nitrate. Nitrate is another oxidizing agent, and in fact that is it takes some more quantity than that of nitrite. You just look at it, nitrate, the concentration can be 0.1 to 0.25. That small quantity is more than sufficient for oxidation. Okay, right. But in the case of nitrate, that is nitrate is given by NO3 minus. This is called nitrate. Usually people add in the form of sodium nitrite and the sodium nitrate, and the combination of sodium nitrate and the sodium nitrite will work out very well. Okay, then so I have discussed the two nitrate, and when you look at the concentration of nitrate, that is, you can understand that the quantity is a little bit more. So here in nitrite 0.1 the starting concentration, whereas in nitrate even you have to take up to 1 gram. But nitrate can be added in as a single pack. Okay, but nitrate should be added as a dual pack only. Okay, right. Then H2O2, you have to consider that is 100% concentration of H2O2, and that should be used to 0.5 gram to 5 gram per liter. Okay, and similarly, but the storage problem is there in case of H2O2, because that will undergo auto oxidation also, and not only that, that is subject to, that is, if there is a light, it will get decomposed. Okay, so storage is a little bit a problem for H2O2. Then meta nitro benzene sulfonate. I will talk about the chemistry behind that. Meta nitro, that is benzene sulfonate. Okay, so let me use this place. Try to understand this. this is benzoic acid. And I write like this. Try to learn some chemistry from me also. So this is benzoic acid. This is known as benzoic acid. And benzoate means it can be sodium benzoate or potassium benzoate. Let me consider potassium or sodium benzoate. So this is the salt of sodium, benzoic acid, sodium salt of benzoic acid, that is sodium benzoate we can call it. And meta-nitro. Meta-nitro means this is the first position, second position, third position. Now second is ortho. This position is ortho and this is meta, this is para. So you can consider the meta-nitro. Do you understand this? So this is known as meta-nitro benzoate of any salt. Okay, right. So that can be added 0.05 gram. So almost that is much more less, very less concentration. So 0.5 gram to 2 gram you can take. And para-nitrophenol. So that is also a very good, that is oxidizing agent, para-nitrophenol. I'll try to write down the structure of para-nitrophenol. Okay, that is, I am giving a lot of series chemistry lectures also. You please go through all those things. That will be very useful, related to you. That will be better. Okay, right. And if you have got any specific doubt, you can ask me in the comments column so that I will be able to give subsequent videos on that, because any subject is ocean. So my lectures are based on your doubts and requirements only. Okay, right. Now nitrophenol. Let me consider this nitrophenol. So this is phenol. You can either way you can draw. Take the benzene structure C6H6. Let me draw phenol. So this is called phenol. C6H5OH phenol. So this phenol in the para position. So para nitro. So para position, that is nitro group is that. So this is called para nitrophenol. Okay. So this is ortho, this is meta, this is para. So para nitrophenol, that is also a wonderful that is oxidizing agent. Okay. So these are the different oxidizing agent, and I would like to add one more sophisticated oxidizing agent like PEI. It's called a polyethylene imine. Okay. And this is used in cold phos and calcium modified zinc phosphate. So please make a note of it, and try to get the that is very good supplier, so that and go through the specs also, and they would have been given some guidelines about the concentration and other specific parameters, and always go by the product data sheet and a material safety data sheet. Kindly go through that, and based on that you can work out the formulations. And then now I would like to share some important special type of trication zinc phosphate coating also. I am not giving the exact formulation. These are all only guidelines. Now zinc 2 plus ion may be present around a 0.3 to 2 gram per liter. Nickel 2 plus, that is 0.3 gram to 4 gram per liter. Manganese 2 plus, that is 0.3 to 2 gram per liter. Phosphate anion. Okay, so actually you are forming three types of layer, that is a zinc phosphate layer, nickel phosphate layer, manganese phosphate layer, and that is why it can be called a trication phosphating system. This is one of the, in fact this phosphate solution bath will be very, very nice, totally greenish. It will be very excellent. And you have to add that is a calcium, or I'm sorry, sodium or potassium fluoride ion, F minus ions, and then here NO3 minus ions, nitrate, and this is nitrite. You just compare the concentration. Here nitrate will be more, 4 gram, whereas nitrate will be very less, 0.1 to 1 gram, and it should be given as a separate pack only. So you should not mix up with this, but you can mix nitrate along with the parent solution. Okay, so always try to give as a 2-pack solution. Okay, there are 3-pack solutions also available that will give very aggressive phosphating. Okay, it all depends on your requirement. Okay, and that phosphate requirement is based on the your customer's requirement in terms of salt spray. For example, some people they may they may insist on 200 hours salt spray, 240 hours salt spray, 400 hours salt spray, 600 hours salt spray, and in certain cases they may expect even 1000 hours salt spray. So depending on the salt spray system, you have to prefer the suitable phosphate system and also the top coat also. Okay, so I hope that is I would have covered the very important aspects about the oxidizing. And the reduction, I already told you, the oxidizing agent itself undergoes reduction. So reduction is nothing but loss of oxygen actually, that is the removal of oxygen, and addition of hydrogen, and that is electronation, adding electron, and the decrease in the oxidation number, and it takes place at the cathode. So cathode reduction takes place, at anode oxidation takes place. And some guys, they are trying for electrophosphating also, where they are attempting that is anodic type of phosphating. So these are all the various one. But if it is the case with the electrolytic coating, means that is it involves a current, and so many people, they are very much interested only in what do you call this kind of electroless coating, like that is phosphate conversion coatings, etc. Okay, so we have got fantastic formulations in nano coating also based on zirconia. So for further details you can contact me. Okay, thank you very much for this video. That is, you have silently and you would have been silently watching this video, and whenever you watch the video, please take down some notes. It will be useful in future also. Okay. Welcome, my dear friends, to my technical series. Many of my friends, they wanted to discuss on this topic. Sir, that is, what kind of services you are providing, so that we will be very much interested to make use of your services in different ways. So for their requirements, it is my responsibility to share my experience and your requirements, in what way I will be helpful as well as a consultant is concerned. Okay. Now, see, that is my paint consultancy services. I have branched this into 10 types. For example, my responsibility is to give the global awareness about the paint making and the appropriate use of that is paint consumption, and particularly for metal finishing industries. Then that is I am doing these services through that is various social media, particularly in YouTube channel. That is, I am promoting some of the important technical series also, so that everybody should understand. And I invite young entrepreneurs, engineers, even some of the guys who are very much interested, even though they are non-technical, but after seeing my lectures, they are very keen in getting some technical information. So it shows that to start a business, that is, it is not necessary that you should be an expert in that field, but with the help of some technical guru, it is feasible. Everything is feasible in this world. Okay, right. But the thing is, that is, you should acquire the technical knowledge with some guidelines. Okay, that is very important. Only thing is, you may ask me, some friends, they ask me, some of my clients, they ask me, sir, you have got, you know something about paint and paint industry, paint making, and how to, that is, analyze the paint defects, and also advise suitable suggestions for automotive industries and other sectors. Then in that case, so why don't you start your own paint industry? Then I used to reply that is, you should have the basic confidence for starting the paint industry, where that is, I am not bold enough, because it is not possible. In fact, starting an industry is not everybody's cup of tea, is it not? So in that case, that is, you should have confidence, and then only you will be able to, that is, survive in this tough business field. So by virtue of my nature, I am fit. I know very well about myself, and I am fit for guidelines only. I am like a lamppost, so that my objective is to teach and to train the guys who are interested, so that they can actively participate, because we cannot that is get all types of works. Okay, so that is some people, they are designed for that, and some people, they are designed only for giving training to others, so that they will make them a successful one. So likewise, that is, I am only a ladder, so that I can support my young guys. Okay, right. Now, Here, my objective is to create global awareness about the manufacturing of paint, either small scale or large scale, as well as what are the problems in that is handling the metal finishing products, and what are the possible defects. All these things I am giving in different social media, particularly YouTube channel. So the guys will be very useful, so that they will have some preliminary understanding about this subject. Okay, but just by going through YouTube's, it would be very difficult to say that they have achieved the that is technical competencies. So you have to go through various that is technical guidelines, technical books, references, and articles, and you should explore some more technical literature survey also in this regard. Okay, I am ready to help you in that is citing pertinent references for making of paint, analyzing the paint, and using the paint in various industries. Okay, right. Now, and we undertake, that is, I cannot myself take a project, but as a team, that is, I can undertake turnkey projects. So I have done various turnkey projects in powder coating, in metal finishing, in establishing the metal finishing workshops, paint shop, powder coating workshops, etc. Okay, and I have done some OEM people also. So you can go through my profile so that you can understand about me in a better way. But my single objective is of late, that is nowadays, that is to promote youngsters in this wonderful field, because if you know the technology properly, and you are a protector, because as I used to say, paint is a wonderful product that can protect any surface and gives aesthetic value, and with all that, nowadays we talk about functional purposes of paint also. Now, here, as I already told you, that is, I have got various engineers in during my course of industrial exposure and my business experience. I have got many people from different walks of life from the paint industries, and I know the best paint manufacturing, raw material resources, suppliers, intermediate suppliers, resin suppliers, and I know the somewhat the best quality, that is manufacturers and machinery equipment suppliers, then additive suppliers, so that I will be in a position to recommend. But once I introduce some guys, means it is up to you to have a better business understanding in credits and debits. That is not my role, and I am least bothered about these commissions. I am not at all interested in any types of commissions for promoting anybody as a single entity. Okay, right. Now, paint formulation and training. So this is another scope where I focus engineers and graduates, so that even entrepreneurs, that is, they can formulate themselves. It is my idea, because I know various guys in this field have spoiled the reputation of some paint consultants just by taking formula from one industry or one company and selling to other people. So I am not the party for that. So in my opinion, as a consultant, as an experienced consultant, I would like to share my knowledge, so that I want everybody to, that is, understand and come out with their own formulation. So for them, I'll be very powerful guru. Okay, right. Now, machinery aspects. So as far as machineries are concerned, as I already mentioned, that is in paint industries, that is, you've got various that is machineries are required, and you should be able to that is identify the, that is the ideal resource persons or manufacturers locally or globally. But the technical service part is very important as far as paint manufacturing and equipments are concerned. Then coating defects. So this is another aspect in the perspective of what you call the paint making as well as paint users. So both of them are very important. I have seen many industries, and I visited many OEM manufacturers and that is engineering industries and automotive industries, where they are struggling for different types of coating defects, like peeling off, rusting, blistering, then adhesion, lack of adhesion, and chalking. So these are all the almost day-to-day problems encountered by the and even by the industries, and even in the phosphate treatment and the nano treatment and the electroplating. So these are all the very that is pertinent problems, but we cannot say that it is a permanent one. There is a very good solution, but it is because of the human intervention that is some of the problems are not sorted out, because it is a this world is something like a world of blame gaming, you know, that is nobody will understand and nobody will accept their fault. If we want to, that is pinpoint a person, definitely he will not accept his fault. So it is better to understand, to identify what has gone wrong, instead of identifying who has committed this mistake. So let us identify the defect of the process, defect or the method, so that we need not, that is have a conflict with the ego of any supplier or end consumer. For example, we have got the best car, but if you are unable to drive the car, you cannot simply blame the manufacturer. But at the same time, there will be some genuine defects also. So in that case, supplier, manufacturer and end user, the customer, they should sit together and they should talk freely, and that too can happen in presence of technical persons, technical consultants like me, so that it should be very useful and you can arrive at some common understanding. Let us try to find out the solution, that is so that it should not recur again. So we should have some standard operating procedure once it is established, means, because you can be totally trouble free also, okay. Because you know very well, the product, the quality of the product depends on the quality of the raw material, how the raw materials are used, how they are stored. All these are very important, okay. So we should arrive at a common SOP, so that even the labor should understand, the labor who is on the particular job should understand, okay. It is not the managerial role only, it is not the responsibility of manager, it should be the responsibility. The quality work should be the basic or essential requirement of every part and parcel of this team, okay. After is the teamwork. Now let me go to the next aspect, machinery. In the case of machinery, as I already explained, that is we are dealing with different type of machinery and coating defect. So here we need to arrive at a common that is SOP for analyzing the code and where it has gone wrong. All these things should be, because it can be from the manufacturer side or the end user side also. So you have to be carefully studying. Then raw materials, as far as the raw materials are concerned, that is we should be, I am able to identify good raw material resources, and even the product I can identify very good customers, so that you can sell your product also. Then materials, I mean monuments. So as far as national monuments are concerned, with the help of wonderful, nowadays we have got smart and sophisticated coatings. With the help of such kind of coatings, I think that is government people also, they can come forward, so that we can provide wonderful conservation for our that is historical and classical and national monuments, okay, right. Then paint testing support. I offer some paint testing support services with the help of my friend circle, so that they are also in need of some basic work, and I can identify some genuine technical persons, so that they will be able to, that is do your testing services properly under my guidances. And metal pre-treatment is another part. Apart from the paint formulation, metal treatment is also very important, pre-treatment. So we have got the different types of phosphating and nano zirconia coating. So for all these things, my consultancy services will be more beneficial to you. And with all that, sir, once I have established the paint industry, then what about the environment and pollution? So that is a very important point. So the safety and the environment are very important of any paint manufacturer. In that case, effluent treatment is a very essential part, and the safety and fire hazards. So these are all the very key area as far as paint is concerned. After all, paint consists of highly inflammable materials, so that we have to be very cautious about the handling and the storage of paint. So in documentations also, my services will be useful, like a material safety data sheet and product data sheets. So for all this is for document purpose, for developing new products, I think my technical services, and with the help of my young guys, the team of young guys, I'll be able to helpful to you. Okay, so thank you very much for watching this video. Hi my dear students, today I'll be discussing about the chemistry of corrosion. Corrosion is the biggest issue in Indian economy, not only in Indian economy, the global economy. Here, the corrosion is nothing but rusting, that is, the oxide film formation on a metal, that is called rusting. In the case of iron, you are able to get that red rusts, and in the case of copper, green rusts. In the case of aluminium, white rusts are formed. And in fact, almost metals are electropositive. Electropositive means they have the tendency to release the electron, and this release of electron is called the oxidation, that is removal of electron, de-electronation. So this is the natural tendency of any metal to undergo oxidation. So metal becomes a metal oxide by the aerial attack in presence of water. So air and water are the two important compounds required for the rust formation. So the metal undergoes oxidation to give metal oxide. As I already mentioned, water and air are the essential components of during the process of rusting, so that the metal becomes a metal oxide film. So once the metal becomes a metal oxide, its strength is weakened, the metal strength is weakened, and thereby it damages the structure, because it is the deposition of these rusts, it is something like a salt, is it not? Iron becomes iron salt, Fe2 plus, okay. So that is why the structure is further weakened. Suppose if the bridge is made up of iron beams, if it is rusted, the bridge may at any time collapse. So how to prevent that? And before that, let us study the mechanism of this rusting. What is the chemistry behind that? So this is nothing but an electrochemical reaction, or you can call it redox reaction. That is, oxidation and reduction, they occur together. Here, when I say electrochemical reaction or corrosion, you should be able to identify the anodic site and cathodic site on the metal. Let us consider this is the iron bar or iron sheet metal or anything like iron rod. So let me consider this iron base, where that is this iron base is exposed to water at one place and exposed to oxygen at another place, and there arises the electrochemical cell, because that is anode is the region of metal exposed to low oxygen content, that is, it is enclosed by water. So that is why this portion is called anodic site, okay, or anode. And what about cathodic site? The cathodic site is the region of the metal where it has the high exposure of oxygen, that is, there will be plenty of oxygen available, and therefore it acts as cathode. You should know one important thing: at anode oxidation occurs, at cathode reduction occurs, okay. So I will explain about these redox reactions, okay, subsequently, right? Now let us talk about the electrochemical corrosion. So in electrochemical corrosion, we have already discussed that is the iron Fe, which is in the solid form as an electrode or metal, okay. So it undergoes oxidation. At anode, oxidation takes place. So oxidation means a removal of electrons. So 2 electrons are removed here, and thereby it becomes the Fe2 plus. So this is the oxidation, and that occurs at anodic site of the metal. And at cathode, of course, its reduction potential is given as E naught is is equal to, you can put E naught like the standard electrode potential of iron Fe2 plus Fe. This is the reduction potential. So its value is 0.44 volt. Okay. Now at cathode, reduction takes place. Reduction means electronation, that is addition of electron. So here oxygen as gas plus, and it may contain the H plus, then electronation, that is addition of electron, so that it becomes what? That is H2O, that is water formation. H2O as liquid. Okay. Now we have to balance this. You can put a half O2. Now it is balanced. But this is the non-stoichiometric equation, that is not proportioned. So it should be converted into a stoichiometric equation so that you can multiply by 2. And moreover, you have got 2H plus, because 2 and here 2 electrons. So 2H plus 2E, it is that is neutralized here, so that you are able to get a neutral one, that is water. Now we have to multiply this equation by 2, so that 2 into half 1, that is O2 oxygen gas, plus 2 into 2 4H plus 2 into 2 4 electron, so that gives 2H2O. So this is the balanced equation for reduction. Okay. So and its value is found to be, that is the reduction potential of this oxygen to water. So it is given as 1.23 volt. Okay. So E0 for this reduction potential of oxygen. Okay. So that is O2. Okay. So that becomes what? H2O. Right. So this one is equal to 1.23 volt. Okay. 1.23 volt. Now let us compare the value of these two. From the value you can immediately say that which can undergo oxidation. In fact, this is the reduction potential. So lower the reduction potential, higher will be the tendency for oxidation. Now let us compare 1.23 and 0.44. So when you compare which is the lower reduction potential, that is iron 2 plus electrode potential, and therefore this acts as anode, and that is why now it is pretty clear that at anode iron becomes iron 2 plus. So this is given in terms of reduction potential. If you want to know the oxidation potential, what you have to do, change the sign so that it becomes minus 0.44 volt, and that is the oxidation potential. But by convention in India, we always interpret the electrochemical series, that is the table of standard electrode potential in reduction potential only. Okay, right. Now we have to combine these two equations. So when you combine these two equations, how to proceed? Now you have to strike out the electrons completely. You have got 4 electrons here, whereas you have got only 2 electrons. So what you are supposed to do? Again you have to multiply by 2. So you can multiply by 2 once again. Then it becomes what? 2O2 here. Is it not? So you can put here. Let me write here. Because you got, this is 4 electron. You have to multiply this equation by 2. So it becomes what? 2Fe, and this becomes 4. Okay, now it's balanced, right? Now this is by convention, anode should be written on the left side, cathode should be written on the right side. Okay, so this is the cathode, and by convention the formula is, that is cell EMF, because we can combine 2 electrode to get the cell, and the cell EMF, that is standard cell EMF, is equal to E right minus E left. Okay, standard potential kept at right side. So kept at right side means at the right side you have got the reduction potential. And what is the reduction potential here? This is how much? And in fact that is for iron, it is minus 0.44. Okay, so minus 0.44. Okay, because it is in the left side. Okay, so you have to put minus here. And what about cathode? Cathode is 1.23. So we have to do, first of all, let us combine these two equations. That is, let us consider this equation as 1 and this equation as 2. Combine these two equations so that you can eliminate 4 electrons. So eliminate 4 electrons. Now combine. So 2Fe plus O2 gas, and this is solid, plus 4H plus gas, that is 2Fe2. Okay, 2Fe2, and what we have, 2H2 plus 2H2. So this is the combined equation. Are you able to follow? And you can put liquid, and this is in the aqueous form, right? Okay, so 2Fe solid plus oxygen as gas plus 4H plus in the aqueous medium, okay, and 2Fe2 plus in the aqueous medium plus 2 water as liquid. This is the cell reaction, that is electrochemical cell reaction of this corrosion setup, okay, right. And what could be its value? This is nothing but E right minus E left. This is the left electrode, this is the right electrode, so you can subtract this, so that now you have got right electrode is 1.23 minus of minus left electrode 0.44. Okay, this is the reduction potential. Now you can get what, 1.67 volt. So this is the cell EMF of what? This electrochemical corrosion of iron. Are you able to follow? So this positive sign indicates that the reaction is spontaneous. So likewise, we can talk about this electrochemical corrosion also. Okay, right. Further, the reaction, that is Fe2 plus ions, Fe2 plus ions can react with oxygen in presence of H plus. So this is the reaction we have already achieved, that is Fe2 plus, and on further addition of oxygen it becomes what? In presence of H plus. Okay, in presence of H plus, and this becomes Fe3 plus. Okay, Fe3 plus, and with the removal of water. Okay, now you can balance this. You can put 2H2O because O2 and 4H plus. Okay, now here, that is, you have got Fe2 plus, right, and you have 4 plus. Okay, so 4 plus plus 2 plus, how much? That is 6. In fact, this is 4Fe, right, 4Fe, and this becomes 4Fe3 plus. Okay, so 4Fe3, because we have to, that is, balance the equation. Okay, so Fe2 plus plus oxygen plus 4H plus, that gives 4Fe3 plus in aqueous form, that is aqueous, as aqueous solution, and this is as liquid. Okay, are you able to follow? Right. Now, and this is the ferrous ion, and this is ferric ion. So the virgin metal surface becomes Fe2 plus by the loss of 1 electron, 2 electron, and on further loss of 1 electron it becomes Fe3 plus. Are you able to follow? And this can become that is a hydrous oxide also, hydrous peroxide. For instance, here once in terms of oxygen, FeO, this is iron oxide, and this iron oxide becomes Fe2O3, that is ferric oxide. This is ferrous oxide, its oxidation state is +2, and here its oxidation state is +3, Fe2O3. And this can be in the hydrated form also, based on the number of water molecules trapped. So you can put hydrated, X moles of hydrated iron oxide, that is Fe2O3, ferric oxide, right? And in fact, this may be the red rust, and it can become a black rust, and it can further become a pitted corrosion also, a pitted corrosion, and now it can even become ferrosoferric oxide like Fe3O4, which is the combination of FeO plus Fe2O3, and it can have a hydrated form also like H2O, X moles of water. Okay, so thereby the hard structure of iron becomes weakened by the formation of deposition of rust, that is rust collection. Okay. Now let us discuss about the methods of prevention of metal corrosion. We can apply oil so that we can avoid rust formation. We can use rust preventive oil for this method, and we can use the greasing technique. You can apply simply grease, okay, so that you can avoid direct water contact. Then galvanizing technique, that is by applying zinc, and in fact zinc as the that is sacrificial protection. This method is called a sacrificial protection, and zinc has the better oxidation potential than the iron, so by sacrificial protection it protects the iron. Your example, you have got galvanized pipes, iron pipes, GI pipe, and then phosphating. So this is another technique by forming phosphate layer over the metal, and this can be followed by painting so that the performance of the paint will be superior. Otherwise, you can go for direct painting by applying some red oxide primer or zinc chromate primer, etc. And when I talk about paint, it can be either that is a liquid paint, or that is a powder coating also. So here we have got the before doing this phosphating, the surface should be very clean. So for metal cleaning, we can adopt sand blasting by physical operation. Otherwise, you can use alkaline degreasing or vapor degreasing. So alkaline degreasing is a water-based one, whereas vapor degreasing is organic one. And followed by, if there is any rust, that should be removed. So we can have de-rusting process. But all these process should be properly cleaned, and the virgin should be very, the metal should be, the virgin metal should be very, very clean, and it should be free from dusts, rusts, dust in any form or rust, and even grease or oil. So it should be totally free from all these extraneous matter, foreign matters, so that the metal can easily undergo the formation of phosphate layer, okay, so that it can have a better adherence of paint also when a paint is applied over phosphating. Otherwise, we can straight away do the painting also. Then zinc plating or electroplating. Then alloy, we can have, for instance, that is alloy coatings also. And passivation, by applying some oxidizing agent, you can further suppress the reactions. And cathodic protection, nowadays protection, like we have got the cataphoretic coating, ED coating we used to say, electrode deposition coating. So these are all very famous method to prevent the metal corrosion. So I hope you would have enjoyed this lecture, and we have got further details about that is the individual part like sandblasting, how to do that, degreasing, alkaline degreasing, vapor degreasing, and how we can do the de-rusting operations, and what is phosphating and what is zinc plating. So these are all the various techniques we'll be discussing further in my subsequent lectures. Thank you very much for watching this video. Welcome, my dear friends. I'm inviting you for this technical series on electroplating and the phosphating, generally metal pretreatment. So here I have given the scope, that is I'll be discussing about the electroplating aspect as well as the phosphating aspect. And prior to that, that is what kind of pre-treatment and what kind of cleaning, de-rusting, de-greasing, all these things should be done. So all these things will be explained in detail in my subsequent videos. So if there is any doubt, you can very well ask me in the that is Telegram itself privately, so that I will be able to respond it. And if it is lengthy, I will be able to give a detailed notes or a detailed video on your doubt. Okay, so get it clarified as and when required. And if you are not in a position to listen to my class online, the best thing is all these are recorded so that you can use it later, but try to complete within 1 month. Okay, so thank you very much. May God bless you, and you will be having a very good successful career and business opportunities in metal pre-treatment. Okay, thank you very much. So with the God's blessing, let us start this today's class. Now let us discuss about cleaning of metals. So the metal cleaning essentially consists of degreasing and de-rusting. So first of all, we will try to understand why we should degrease and why we should de-rust. The major problem with any metal component is that is oil. Not only oil, the metal should be free from oil, lubricants, because during the formation they would have used some lubricants, and respiratory oil is also applied, and then grease. Then it should be free from rust, and the heavy rust is called scale. Then dust in any form, there should not be any smudges or mud or sand, and the welding scale should not be there, and there should not be any tool markings also. So all these things should be taken into care, and in fact we have to be very careful to remove all these from the metal surface. Now degreasing, we can degrease, that is remove oil or lubricant or grease from the metal surface by using alkaline cleaners. So essentially it contains sodium hydroxide, caustic, okay, sometimes potassium hydroxide, it depends. And apart from that, we have got other ingredients also. I'll be discussing about this in the composition of degreasing agent, okay, right. Now emulsion, so we can make use of emulsion also. What is emulsion? For example, you have got oil and water. These two are immiscible. Okay, when you mix it, they are immiscible. They get separated as two layers, and by introducing some detergent or soap, we can make it uniform. That results emulsion, a milky liquid. Okay, and that is why this soap is called the emulsifier, is it not? And generally these emulsifiers, they have, in fact, why oil and water are immiscible? Oil is non-polar, whereas water is polar, and that is why they are not miscible. So in order to make them understanding, we need to use an agent which has both non-polar and polar character. So in that case, any soap, for example, when you call soap, it is nothing but it is the sodium or potassium salt of long chain fatty acid. So long chain fatty acid means we can take stearic acid and oleic acid, etc. So acid means a carboxylic acid, that is organic acid. Okay, and the basic acid is formic acid, acetic acid, propionic acid, butyric acid, etc. So likewise the carbon chain increases, and that is called long chain fatty acid, and the terminal group will be having COOH group, where we used to esterify with some potassium or sodium salt. And in fact oil itself is a triglyceride of long chain fatty acid. It's a triglyceride. So we can break this and make it as a soap, and that soap, either oil based soap or totally that is synthetic detergents. So generally synthetic detergents are used here, and that is why in alkaline degreasing we straight away use the alkali, whereas in emulsion we use the emulsifier. Okay, and there are so many types of emulsifier also. Based on the requirement under the composition of emulsifier, we'll be discussing this. Then we can use the solvent also. So some people, they are interested to clean it with only solvent without wasting the water. So in that case, you can make use of solvents. Okay. So we used to say TC, trichloroethylene, all these things can be used. And there are some vapor degreasing methods also. Then de-rusting. De-rusting is a process where the metal oxide is removed. Actually, that is rusting is the process of conversion of metal into metal oxide. So that metal oxide layer is loosely held, and that should be removed. Otherwise, our paint will not be adherent to that. So we have to remove that one, and not only that, it will be corrosive, it will cause rust, it will result in pitted corrosion. So it has to be removed. So this metal oxide film is removed by using acid. So then in that case, it's called acid pickling. And when we can make use of alkaline chemicals also for de-rusting. And in certain cases, physically we can do the abrasive blasting. That is, you can do the sand blasting or grit blasting. That is, the sand is pressurized sand is allowed to, that is made an impact on the components, so that with high pressure this sand will be blasted on the rusted or scaled metal components, so that the cleaning can be effectively done. Okay. But essentially, after sandblasting, you must be sure that these trapped sand particles and other dust should be thoroughly cleaned before painting or plating or zinc phosphating. Okay. Done. Okay. But essentially, after sandblasting, you must be sure that these trapped sand particles and other dust should be thoroughly cleaned before painting or plating or zinc phosphating. Okay. Done. Okay. But essentially, after sandblasting, you must be sure that these trapped sand particles and other dust should be thoroughly cleaned before painting or plating or zinc phosphating. Okay. Done. Okay. But essentially, after sandblasting, you must be sure that these trapped sand particles and other dust should be thoroughly cleaned before painting or plating or zinc phosphating. Okay. Done. Okay. But essentially, after sandblasting, you must be sure that these trapped sand particles and other dust should be thoroughly cleaned before painting or plating or zinc phosphating. Okay. Done. Okay. But essentially, after sandblasting, you must be sure that these trapped sand particles and other dust should